Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih. Surakarta, jiwa dari Pulau Jawa, kekayaan budaya yang terus terjaga, melahirkan jiwa-jiwa bersahaja, menciptakan para intelektual muda yang siap mendunia. Di sini berkembang Persyarikatan Muhammadiyah, organisasi Islam progresif yang bergerak di bidang kehidupan, salah satunya pendidikan. Atas prakarsa Dr. Andes Haji Muhammad Jasman, pada tahun 1979, Universitas Muhammadiyah Surakarta berdiri sebagai gabungan dari Institut Keguruan dan Ilmu Pendidikan Muhammadiyah Surakarta dan Institut Agama Islam Muhammadiyah Surakarta. Universitas Muhammadiyah Surakarta hadir memberkaya kemampuan para intelektual muda, mewujudkan sarjana muslim berakhlak mulia, cakap, percaya diri, mampu mengembangkan ilmu pengetahuan dan teknologi yang berguna bagi umat, bangsa, dan perkembangan dunia.
Program Studi Pendidikan Matematika, Fakultas Keguruan dan Ilmu Pendidikan, Universitas Muhammadiyah Surakarta, berdiri pada tanggal 9 Maret tahun 1984 berdasarkan SK Menteri Pendidikan dan Kebudayaan Republik Indonesia. Sejak berdiri, pada bulan Maret tahun 1984, Program Studi Pendidikan Matematika (knpmp.ums) senantiasa berkomitmen mengembangkan pendidikan matematika yang profesional dan inovatif, serta mengusung nilai-nilai keislaman yang merupakan perwujudan kesadaran sebagai lembaga di bawah Persyarikatan Muhammadiyah.
Di bawah pengelolaan yang profesional menuju world class quality, Program Studi Pendidikan Matematika Universitas Muhammadiyah Surakarta hadir dengan visi menjadi pusat pengembangan pendidikan matematika yang profesional, inovatif, dan islami. Dengan misi menyelenggarakan proses pembelajaran secara profesional, kreatif, dan islami, melakukan inovasi pendidikan matematika, serta menjalin kemitraan untuk meningkatkan kapasitas institusi. Program Studi Pendidikan Matematika berupaya menghasilkan pendidik yang mampu mengelola pembelajaran matematika dan menghasilkan karya-karya inovatif di bidang matematika dan pendidikan matematika. Sejak tahun 2018, Program Studi Pendidikan Matematika Universitas Muhammadiyah Surakarta telah terakreditasi A. Penciptaan atmosfer akademis dan pembentukan karakter kompetitif terus ditingkatkan, sehingga kepercayaan masyarakat terhadap program studi pendidikan matematika Universitas Muhammadiyah Surakarta semakin tinggi. Hal ini terlihat dari banyaknya jumlah peminat yang mendaftar. Pembelajaran di program studi pendidikan matematika Universitas Muhammadiyah Surakarta didukung dengan fasilitas penunjang yang baik, seperti sarana perpustakaan, tempat mahasiswa dapat mengakses referensi yang relevan dan memadai, laboratorium pembelajaran, laboratorium komputasi, bengkel dan ruang display alat peraga matematika, Masjid Fadlur Rahman dan Masjid Hajah Sudelmiah Rais, serta Wi-Fi area. Program Studi Pendidikan Matematika juga menaungi langsung himpunan mahasiswa Program Studi Pendidikan Matematika yang mampu menjadi wadah bagi mahasiswa untuk mengembangkan soft skill di bidang organisasi dan pengembangan diri. Selain didukung oleh fasilitas yang mumpuni, atmosfer akademis juga dibangun melalui tenaga pengajar yang telah tersertifikasi, baik secara akademis maupun praktis. Terlibat aktif dalam kegiatan akademis dan profesi berskala nasional maupun internasional, sebagai upaya pembaharuan ilmu pendidikan matematika yang dimiliki. Proses pembelajaran juga mengacu pada kurikulum berbasis kompetensi yang merujuk pada KKNI, Kerangka Kualifikasi Nasional Indonesia, melalui pendekatan metode pembelajaran saintifik, kooperatif, konstekstual, discussion, presentation, dan problem solving. Berbagai upaya yang dilakukan program studi pendidikan matematika Universitas Muhammadiyah Surakarta melalui pemberian fasilitas penunjang hingga menjalin kerjasama dengan instansi di dalam maupun luar negeri yang merupakan proses penciptaan atmosfer akademis yang kondusif. Diawali dengan kesadaran bahwa kecerdasan dan kesejahteraan umat adalah tanggung jawab bersama, sehingga memberikan yang terbaik dalam membentuk generasi penerus bangsa adalah satu tanggung jawab yang patut ditempuh untuk menjadi yang profesional, inovatif, dan islami dalam dunia pendidikan matematika nasional maupun internasional. Program Studi Pendidikan Matematika Universitas Muhammadiyah Surakarta. Profesional, inovatif, dan islami.
Sukses sebagai pelopor One Day Service, kini Universitas Muhammadiyah Surakarta hadirkan terobosan terbaru, e-seleksi. Kamu dapat mendaftarkan diri dengan mengakses e-seleksi.pmb.ums.ac.id. Lengkapi biodata diri kamu dan unggah nilai rapor serta prestasi kejuaraan yang pernah kamu peroleh.
Mari bergabung dengan Universitas Muhammadiyah Surakarta, kampus terbaik nasional terakreditasi A. Daftarkan diri Anda cukup dari rumah dengan mengunjungi e-seleksi.pmb.ums.ac.id.
Mau tahu cara daftar kuliah di UMS? Ikuti cara aku. Pertama, ambil gadget kamu. Kedua, lalu buka e-seleksi.pmb.ums.ac.id di browser favorit kamu. Ketiga, pilih daftar e-seleksi. Keempat, buat akun kamu bebas dan ingat jangan sampai lupa passwordnya ya. 5. Lengkapi data diri kamu dan pilih program studi yang kamu minati. Keenam, login akun kamu. Ketujuh, lengkapi semua syarat administrasinya. Jangan lupa upload nilai rapor kamu dari semester 1 sampai 5, prestasi juara, dan surat sehat dari dokter. 8. Lanjut deh, bayar uang pendaftaran Rp200.000 melalui transfer bank. 9. Jika kamu diterima, buruan selesaikan administrasinya dan upload kembali semua struk pembayaran dan bukti registrasi kamu. 10. Pastikan kamu sudah dapat notifikasi selamat telah menjadi mahasiswa UMS di prodi pilihan kamu. Mudah kan? Yuk buruan daftar, kuota terbatas.
Recording in progress. Recording stopped. Recording in progress.
First of all, to all participants, you are all advised to use the virtual background. Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In the name of Allah, the most gracious, the most merciful. The Honorable, the keynote speaker, Bapak Professor Insinyur Nizam MSc PhD, Director General of Higher Education, Ministry of Education and Culture, Republic of Indonesia. The Honorable, the invited speakers, Associate Professor Tohtin Lam from National Institute of Education and Nanyang Technological University, Singapore. Dr. Sulyadi Firdaus from University Tun Hussein M, Malaysia. And Professor Sutama MPD from Universitas Muhammadiyah Surakarta, Indonesia. The Honorable, the head of the International Conference on Mathematics and Learning Research, Bapak Dr. M. Nur Khalid MPD, and the audience. Praise be to Allah Subhanahu wa Ta'ala, the cherisher and sustainer of the worlds. Salawat and salam may everlastingly be upon our adoration, Rasulullah Sallallahu Alaihi Wasallam, who had guided and led us from the darkness into the shining bright path. The Honorable audience and distinguished guests, I am Belfa Amalia as the Master's Rominator Deck. Welcome to the International Conference on Mathematics and Learning Research on Wednesday, August the 11th, 2021. Let's start this event by reciting Basmalah together. Bismillahirrahmanirrahim. Ladies and gentlemen, now we're going to listen to the Quran recital by Afwa Hudiagama with the Surah As-Saf, verse 10 to 13. The Honorable Afwa Hudiagama, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. يا أيها الذين آمنوا هل أدلكم على تجارة تنجيكم من عذاب أليم. تؤمنون بالله ورسوله وتجاهدون في سبيل الله بأموالكم وأنفسكم، ذلكم خير لكم إن كنتم تعلمون. يغفر لكم ذنوبكم ويدخلكم جنات تجري من تحتها الأنهار ومساكن طيبة في جنات عدن، ذلك الفوز العظيم. وأخرى تحبونها نصر من الله وفتح قريب. نصر من الله وفتح قريب. وبشر المؤمنين. صدق الله العظيم. جزاكم الله خيرا. السلام عليكم warahmatullahi wabarakatuh.
Thank you, Afahudi Agama. Ladies and gentlemen, it is time to carefully listen to the national anthem. To all participants, you are advised to stand. The national anthem, Indonesia Raya and Sang Surya.
Jaya
Thank you. Happy audience, the upcoming session is opening remarks from the Chief Committee of the International Conference on Mathematics and Learning Research, the Honorable Bapak Dr. and Nur Khalid MPD. The floor is yours.
Thank you, Ms. Bilva. Assalamualaikum warahmatullahi wabarakatuh. Dear Rector of Universitas Muhammadiyah Surakarta, Bapak Profesor Sofyan Anif, Vice Dean of FKIP, Ibu Mauli Halwat Hikmat PhD, invited speakers, Professor Insinyur Nizam MSc PhD, Associate Professor Tohsin Lam from Singapore, Dr. Suliadi Firdaus from Malaysia, Professor Sutama from Universitas Muhammadiyah Surakarta, committees, authors, and listeners. We highly appreciate your participation in the schedule because your participation provides a significant contingency. ICOMER head by Mathematics Education Department Universitas Muhammadiyah Surakarta, Indonesia. It is a follow-up activity of the Konferensi Nasional Penelitian Matematika dan Pembelajarannya, or knpmp.ums. We invite undergraduate, graduate, doctoral students, teachers, lecturers, and observers in mathematics and mathematics education to disseminate their research result. Often when I meet people for the first time and tell them that I'm a math educator, the majority of the time I receive directions such as, oh, I had mathematics at school, and I'm just not a math person. This reaction dramatically saddens me, but is the product of your exposure to the thrill and kill approach to math learning. With the exponential growth in technology, knowledge has become a commodity. Our student can Google any answer or technique maybe. So education needs to teach students what to do with the knowledge and how to apply and how to transfer the knowledge to different situations. Math learning should be about developing conceptual understanding to prepare our students for the 21st century. Successful 21st century math learning needs to foster 21st century skills such as communication, collaboration, critical thinking, and problem solving. We took the technology-based experiential learning to enhance 21st century math skill, and to answer this situation, we invite all speakers here. The honorable audience and distinguished guests, we need to confirm that this event is supported by a paper of 80 and 60 participants, and also 30 reviewers from Indonesia and overseas. We also work with cooperation with AIP and Jeramatedu. AIP is Corpus Index Proceeding, while Jeramatedu is indexed in Sinta 2. Finally, for the honorable audience and distinguished guests, we also apologize for the lack of implementation of this event, and we try to provide maximum services and design implementation that ensure the safety for everyone. Once again, we would like to say thank you and highly appreciate your participation. Glad to see you at the conference. Stay safe and healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Bapak Dr. Nur Khalid MPD. Ladies and gentlemen, now we're going to have the another speech from the Vice Dean of FKIP UMS, the Honorable Ibu Mauli Halwat Hikmat PhD. The floor is yours.
Thank you. Good morning. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Director of Universitas Muhammadiyah Surakarta, the Dean of the Teacher Training and Education Faculty, the distinguished speakers, Professor Nizam, PhD, from the Ministry of Education, Associate Professor Tohtin Lam, PhD, from Singapore and Nanyang Technological University, Singapore, Dr. Suliadi Firdaus from University Tun Hussein on Malaysia, Professor Dr. Sutama from Universitas Muhammadiyah Surakarta, our distinguished guests and conference participants, ladies and gentlemen, allow me in this opportunity to welcome you all of this conference by first praying our grateful and praise to the Almighty God for all His blessings, grace, and mercies that have made us possible to gather here in this room in excellent condition and health. This is the first conference, the first international conference held by Department of Mathematics of Teacher Training and Education Faculty with the theme about the technology and the 21st century. And this is the first international conference. Since the world today is facing many challenges as for teachers, providing students with the 21st century skills is very important. We should be aware of the importance of the implementation and the integration of the skills in teaching and learning, including in teaching maths. A bulk of research on the subject have shown that one factor of success is the ability to cope with the skills needed in the 21st century, including knowledge, skills, work habits, and character traits. So, as teachers, we have to be able to provide students with critical thinking skills, creativity, collaboration, communication skills, literacy, information, technology, media, flexibility, leadership, initiative, productivity, and social skills. So this conference is one of efforts that is held by the Department of Maths to give contribution to help students keep up with the light of space of today's modern need. This international conference is one among many efforts to enhance nation productivity and competitiveness. Hopefully, we all can significantly give more contribution to the nation. To all of our participants, thank you for being here. Welcome and enjoy the conference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Ibu Mauli Halwat Hikmat, PhD. Ladies and gentlemen, we finally come to the awaited moment, the keynote speech session. But before it begins, let me read out the curriculum vitae of the keynote speaker. Bapak Profesor Insinyur Nizam MSc PhD, the Director General of Higher Education, Ministry of Education and Culture, Republic of Indonesia. He has finished studying in Universitas Gadjah Mada, Indonesia in 1985 and in Imperial College of Science and Technology, University of London, United Kingdom in 1989 and 1992. He has been participating in some professional organizations, consist of Indonesian Association of Hydraulic Engineers, International Association for Hydro Environment Engineering and Research, and the Global Development Learning Network Asia Pacific. Besides, he also has some publications through years. Now please welcome our keynote speaker, Bapak Profesor Insinyur Nizam, MSc PhD, Director General of Higher Education, Ministry of Education and Culture, Republic of Indonesia. The Honorable Bapak Profesor Insinyur Nizam, MSc PhD, the floor is yours.
Thank you, Mbak Belva. Assalamualaikum warahmatullahi wabarakatuh. Good morning to all of you. Shalom, Om Santi, Namo Buddhaya, Salam Kebajikan. Honorable Professor Sofyan Hanif, Rector of UMS, distinguished participants, keynote speakers, invited speakers, and colleagues from UMS. First of all, Alhamdulillah, we all in good health to have this very important international conference on mathematics and education research. I would like to share with you presentations on the emancipated learning through the Campus Merdeka program at the Ministry of Education, Culture, Research and Technology. So as this is an overview of Indonesian higher education system. As mathematicians, numbers is important. So first, there are quite a lot of higher education institutions in Indonesia, more than 4,000 institutions, large and small, and it consists of 29,000 study programs, catering for almost 8.5 million students all over the country, from Aceh to Papua, with more than 300 lecturers. And as we know, currently we are in the time of disruption with the Industrial Revolution 4.0 that impact many fields of the way we are doing things. Our daily lives, our economy, even our jobs is different due to digitalizations and the revolutions 4.0 in the industry. But it is more deeper than just the industry. The society is very much disrupted by the revolutions. And according to McKinsey predictions, in Indonesia alone, more than 23 million jobs will be replaced by automations, by smart system, by machine learning, by artificial intelligence, Internet of Things. So those will replace many jobs in Indonesia. But aside from the job loss, there are opportunities for new jobs to be created. More jobs can be created rather than compared to job loss. Double that numbers is the opportunity, or the opportunity of jobs can be created, and millions of them has not yet existed now. As we can, if we reflect back 10 years back, many of things which now become common was not there. For instance, e-banking, it is a new thing. The online e-commerce and many things are not yet exist 10 years ago. So every student that now in the university, when they graduate, the word they enter will be different from the words they enter when they enter the university. It is a big challenge for university to prepare new skills not yet known. We have to prepare graduates to be more adaptive, more agile, self-directed, entrepreneurial, and of course they will face more complex words. So complex problem solver, and digital literacy is a must, and multidisciplinary approach to any problems. Given the natures of the problem become more complex, multidisciplinary approaches become very important. So the skills to collaborate, the skills to work across disciplines is really competencies that need to be developed during university life. And of course, global citizenship is also very important given the globalized world. So we do not want to have a broken link between the higher educations to research and educations and the world of work that move very fast, transform very fast. So we have to assure that there's no broken link between what is taught in campus, what skill, what competencies we prepare for students with the development and the need of the professional world. If we reflect, we always lag behind the word of professional. Why? Because when we develop curriculum, it based on what happened now and based on the feedback from our graduates that has graduated in the past 5 years. We plan for the curriculum for the next 5 years. So when the graduates came out from university 5 years from now, the world already changed. So university always lag behind the word of the profession. So to make sure that there's no broken link between educations and the professional work, we have to marry them. We have to marry them between the campus and the world of the profession of the job market. So that is the spirit of the Campus Merdeka. To do that, we transform education from narrow and prescriptive way of preparing graduates into self-directed and more flexible learning. This is the emancipated learning principle. We develop multiple pathways of our students in developing their potentials, their talents, and passion by giving them opportunities to take minor subjects from other disciplines or mix of subjects from many study programs outside their major, their main subject. For instance, science and math students can take subjects from economics, for instance, or can take subjects from social sciences or philosophy or any other subjects that students aspire to learn from. And also the opportunities up to 2 semesters, up to 1 year to do experiential learning from outside their own campus. So students can engage with the real professional world that they aspire to enter, of course, under the supervision of the professor from their own university. So this develop the pathways of students to be more ready, more prepared with the development of the world of the profession. So that off-campus activities can be taken in multiple ways. One, it can be student exchange. Students from UMS can spend 1 semester in Universitas Kebangsaan Malaysia, for instance, or can spend 1 semester in European universities or in other university in Indonesia. So that way, students can have can be more agile and can be more open-minded, as well as the communication skills, intercultural, interprofessional can be developed. And second, internship in whatever profession students aspire to be when they graduated. It can be in banking, it can be in the industry, or it can be in government bureaucracy, or it can be international organizations and whatever students aspire to work in the future. And those that aspire to be teachers, they can do teaching while they are still students, assisting teachers in remote schools across the country. And research assistantship is, of course, one important aspect that students might aspire to be. They want to be a scientist, they want to be lecturers, so they can be a research assistants full-time. All these are full-time, and all are given credits for the effort that they do. up to 20 credit for one semester or 40 credits if they spend 1 year. And they can also join humanitarian activities, entrepreneurships. Those that aspire to be an entrepreneur can start the entrepreneurships while they are still students. So when they graduate, they already have a startup company, for instance. Micro-credentials, this is independent project, independent study, student can take through any of the opportunities in the micro-credentials world. And community empowerment is also very important activities that students usually aspire. And this can be for activists that would like to develop the community, to help with the remote village to develop. And another off-campus activities is military service. So this year, those off-campus activities we prepared at national level, as well as every university can develop their own program for these up to 2 semesters off-campus activities. For instance, this is the program that's offered nationally. We prepare more than 80,000 places for students to join these activities. Like for the micro-credentials, close to 10,000 places are for the micro-credentials. The community development, more than 20,000 students joining that activities. Internship in industry, 15,000 places, and students are given, for instance, students from Papua, if they want to have internship in Jakarta, so the cost of travel and some support for cost of living while in Jakarta is provided by the government. And student exchange, 20,000 for national exchange and 1,000 for international student exchange. This has been selected this year, and they already on board to Europe and America and many other countries. And Kampus Mengajar, the teaching, 35,000 place for students to engage with local teachers in remote places. Last semester, about 15,000 students joining these activities, and they do amazing things. And student entrepreneurships is also an area that we would like to accelerate. And for that, government funding to transform higher education to be more agile, to be more fit with the development of the fourth industrial revolutions, is one of the instruments is through funding. One, based on key performance indicator achieved by universities, especially this is for public university. So we provide support for public university based on their key performance indicator. And this is the matching fund for support of university industry cooperations, 25 billion rupiah. We prepare for that, and 500 billion rupiah for competitive fund of Kampus Merdeka competitive program. This is to accelerate the transformation of university study programs to fit with the development of the professional world. And a lot of sum of money go into the Emancipated Learning Kampus Merdeka program. So through this funding mechanism, we would like to accelerate the collaborations between university, the business world, industrial world, community, the banking, financing, government, and media. So we can term it as N-helix or hexahelix or double, triple helix, to make sure that there is no gap between the professional development with the social development, with the community development, and what university is doing. So there will be no technological gap, and we can upstream all the industrial problems into to become the research agenda, to research topic, and go into curriculum directly, and go into the classroom to transform the classroom to be more participative, more based on real case from the industry, from the society. Whereas we can also downstream university research results, innovations into the industry, and the graduates go into industry with skills, soft skills, and hard skills, they already prepared with through collaborations and engagement, deep engagement with industry while they are still students. So that is the Campus Merdeka program. And we open for collaborations from partners, from industry and from universities abroad. Through University Consortium, we would like to invite a consortium of university based on subject like in math, in science, in education, and whatever. And joint project and research and publications, we provide support for our professors, for our lecturers who like to have a joint research with colleagues from abroad. And curriculum development, joint curriculum development, student and staff exchange, internship in industry, scholarships, sabbatical leave for professors. We also welcome world-class university to come to Indonesia through a joint program with local universities. And also for micro-credentials, industries and university can offer micro-credentials for students to take, and online learning development during this COVID-19 is also an area that we can collaborate. Currently, through ICE Institute, many international university has joined offering the online learning through the ICE Institute platform. And thank you very much for the opportunity, and wish you all a successful international conference and a fruitful discussions to bring home with you. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Sir Insinyur Nizam. Ladies and gentlemen, now it comes to the welcoming speech from the Vice Rector, Universitas Muhammadiyah Surakarta, Cooperation and International Affairs, Bapak Supriyono, STMT, PhD. The floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time. Alhamdulillah, alhamdulillahirabbil alamin. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma shalli ala Muhammad wa ala ali Muhammad. The Honorable, the General Prof. Nizam, the Director General of Higher Education, Ministry of Education, Culture of Republic Indonesia, Honorable Speakers, Associate Professor Toh Tin Lam from National Institute of Education, Singapore, and Nanyang Technology University, Singapore. The second speaker, Dr. Suliadi Firdaus from University Tun Hussein on Malaysia. First of all, I would like to convey the apologies from my rector. He cannot join this moment because at the same time, the rector, we have a graduation, and currently is the peak of the event, so he cannot join this event. So the rector apologizes for this case. Secondly, I would like to welcome you all to University of Muhammadiyah Surakarta. I hope Universitas Muhammadiyah Surakarta is not a strain for you. Just to let you know that Universitas Muhammadiyah Surakarta is the biggest university under Muhammadiyah organization. As you know, Muhammadiyah organization is the biggest Islamic organization in Indonesia. Thank you for coming to Universitas Muhammadiyah Surakarta, and we are very happy because of this event. This is the International Conference on Mathematics and Learning Research. From this conference, we hope we can have something that something that can be used to develop, especially in mathematics and learning research. I hope this conference is going well, and once again, we welcome you all, both for the participant as the speaker. Thank you very much for being attend to this event. That's all. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Bapak Supriyono, SDMT PhD. Ladies and gentlemen, now it comes to the panel session. We already have Associate Professor Tohtin Lam, Dr. Sulyadi Firdaus, and Professor Sutama MPD with us as the invited speakers, who will be managed and moderated by Bapak Naufal Ishartono MPD. But before it, I will read out the curriculum vitae first. Bapak Naufal MPD, the Head of Learning Sources Development and Research Publication of FKPUMS, from the Department of Mathematics Education, Universitas the editorial board of the JRA Math Education, OSINTA 2, and IGO LAE. Besides, he also has some publications, including 32 journal articles and proceedings. The Honorable Bapak Naufal Ishartono MPD, the floor is yours.
Hey, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Mbak Belva. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrofil anbiya'i wal mursalin wa ala alihi washabihi ajma'in wa ba'du. Praise to Allah Subhanahu wa Ta'ala with His blessing, hidayah, inayah, so we can be here together in good conditions in the ICOMER 2021. And moreover, may salawat and salam be upon our Prophet Muhammad sallallahu alaihi wasallam, his family, and all his companions. Thank you, Ms. Belva, for introducing me as the MC of as the moderator of today's conference. So, ladies and gentlemen, my name is Naufal Ishartono. So, in here I will accompany you as a moderator for today's conference. Ladies and gentlemen, please allow me to do the start script. I have prepared some, wait a minute. Okay, so ladies and gentlemen, today's conference arises the theme of technology-based experiential learning to enhance 21st century math skills. So, we as the committee of the first ICOMER 2021 believe that we profoundly believe that this issue should be raised because based on the survey and the report that is published by McKinsey and Company in February 2021, 28 February 2021, that it says that there are a lot of jobs that will lose and vanish after the COVID-19, and therefore, in addition. McKinsey said that COVID-19 may propel faster adoption of automation and NI, especially in work arenas with high physical proximity. What does it mean? It means that we have to prepare all of the people in society, all of the people around the world, all of the generations with skills that can accommodate for people to compete in the global competitions. And next, this is what the World Economic Forum says, that after 21st century, we have to master. I mean, all the generations, all the people for the world have to master some skills that enable them to survive along along their life in the future. Anyway, so in here I will highlight some skills that needs to be possessed or need to be mastered by our generation or maybe a next generation. Is that we see in here we have literacy, numeracy, scientific literacy, numeracy, scientific literacy, ICT literacy, financial literacy, and in here we have critical thinking, creativity, communication, collaborations. With these two, the purple and the, let's say, yellow area, we believe that those skills can be grouped as math skills. So I believe that in here, in this ICOMER 2021, by erasing the themes of the conference, we believe that we can make a good discussions on how to prepare our generations. But the big problem or the big question is that how we can do that. So in here, ladies and gentlemen, in here, the ICOMER 2021 has invited three prominent speakers in here. First is Mr. Toh Tin Lam, PhD from Singapore, Mr. Dr. Suliadi Firdaus bin Subhani from Malaysia, and Professor Dr. Sutama from Indonesia. But beforehand, before I give time for those speakers, I will introduce you by reading their curriculum vitae. From Mr. Toh Tin Lam, PhD, name is Associate Professor Toh Tin Lam, PhD, Institution Nanyang Technology University, Singapore. And his expertise is stochastic integration theory, Hausdorff integrations, mathematical problem solving. Scopus its index is 5, education background. He holds his doctoral degree from National University of Singapore in 2001, in the field of mathematics. He also finished his bachelor and master degree in the same university in 1994 and 1996 respectively. And current position is at the present, he sits as a head of mathematics and mathematics education academic group in National Institute of Education, Singapore. A journal editorial board, he is editor of Zeramat Edu, that his collaboration for today's conference as a publication channel, and also his editor board of IGTLM for Indonesia. He has a lot of books. We have 90 books, chapter and 4 books. Funded project, 9 projects that were awesome. International experience, 9 times as invited lecturer and keynote speakers since 2018. And publication, 44 journal articles and 30 proceedings. Mr. Toh Tin Lam, are you with us? Mr. Toh Tin Lam?
Yes.
Okay.
Yes.
Yeah, welcome to our conference, Mr. Toh Tin Lam.
Thank you.
Okay, thank you, Mr. Toh Tin Lam. For the next speaker will be Dr. Suliadi Firdaus bin Subhani. He is a lecturer from University Tun Hussein, Malaysia. His expertise is mathematical sciences, specialization applied mathematics. Scopus its index is 10. And educational because he holds his doctoral degree in University of Sheffield, UK, and University of Technology, Malaysia. Working experience at the present, he sits on many prominent academic positions, such as the head of statistics panel in UTSM, a senior researcher in Malaysian Research Institute for Vocational Education and Training, a principal researcher in OSIS integrated group, and many more. Because I see from his curriculum vitae, there's a lot of job that he have to do. Journal editorial, Journal of Science and Technology from Malaysia, International Journal of Soft Computing and Materialistic. Books, he has 3 international books that published by Amazon and 1 national book that published by UTSM. And patents, he holds 2 patents and IPR, intellectual that is copyright, has 58 copyrights. So Dr. Suliadi, are you with us? Dr. Suliadi? Okay, not yet. Oh, okay, so Dr. Suliadi will catch up. Okay, our last but not least speaker today is Professor Dr. Sutama, MPD. So this is from Universitas Muhammadiyah Surakarta, Indonesia. His expertise is on mathematics education, especially in learning media, mathematics learning media. Scopus as index is 3. And educational background, he holds his doctoral degree in Universitas Pendidikan Indonesia, UPI. Working experience, at the moment, he is the Dean of the Faculty of Education and Teacher Training Universitas Muhammadiyah Surakarta. He is also a chief editor of Faradika, editorial board of Undagdikdas, and also publications. He has 555. That's a good number. publication of research paper and books based on Google Scholar. And the IPR is 3 copyrights, and research grants has a lot of research grants. DRPM, some of them are DRPM, MPM, PTUPT, Master Thesis Research, Postgraduate Research, DRPM Research Grant. Okay. Since Professor Dr. Stama at the moment is still holding on the graduations, so probably Professor Dr. Stama has sent us the video that we will play later on after Mr. Toftin Lam and Dr. Suliadi Isfani has delivered their presentation. So after that, we're going to play the video of Professor Dr. Stama's presentations. So let's go to our first speaker, Mr. Toftin Lam.
Yes, thank you so much. Please allow me to share screen.
Oh, sure. You already have you have already been
yes.
Yeah, I think you
fine.
can share screen. Okay, so you have 30 minutes with Dr. Lam, so hopefully the times and the floor is yours, please.
Thank you. Good morning, everybody. Can I just check, can you hear me? This is the most important thing when we meet through the Zoom. Are you able to hear me?
I can hear you.
Thank you so much. Thank you, thank you. Okay, so first of all, I would like to thank the organizing committee for inviting me to this international conference. And after some thought, because I realize it's related to technology, and I will share something that is closest to my heart and which is currently what I'm doing now in my university as part of the research, which is on the teaching and learning of calculus. Calculus is something that is important, especially for STEM education. And I have been thinking through the past data collection, what is the way to talk about the teaching of calculus and what are the problems that we are encountering currently. Of course, a lot of the context that I'm talking about is based on my experience in the research that I conducted in Singapore. But some of this experience, I believe, may be helpful to you. And of course, one of the most important thing is the use of technology to facilitate the learning of calculus is something that I would like to emphasize. And as my talk continues, I would share with you some of the ideas and some of the research that we have conducted in Singapore. Calculus is an interesting topic. It is at the school level, and unfortunately, based on the experience and based on research papers, many school students find calculus difficult. I have conducted a survey this year in a ZDM paper, and that was actually shows that many of our brightest students in Singapore also find calculus difficult and have a lot of misconception. So some of the reasons that we find is that there is an overemphasis on procedural knowledge over conceptual understanding. I'm not sure about the Indonesian context, but in the Singapore context, our teachers place a lot of focus on getting the students to know the procedure without really knowing the concept. We can't really blame them because calculus is something that's difficult. And also there's an overuse of symbols without emphasizing on the meaning. You use the symbol dy dx and you use all the sine inverse, cos inverse, and all the funny notation, but what exactly is the meaning? And of course, not only students, but even teachers, school teachers find the calculus difficult. Why did they find calculus difficult? Because in the university mathematics that they learn, they have not learned much about school calculus. This is an important thing. Teachers also have not learned much about school calculus. They only go through experience as a school student with which they carry with them much misconception. When they come to university, when they learn the university mathematics, they also might not have actually create the misconception. So that's why these difficulties and this misconception perpetuates from students to teachers. And this is something that is interesting, that deserves our attention. Now, one of the most important things why calculus is difficult is because many of the terms that we use in calculus are not congruous to the terms that we use in the real world. One of the words that we always use in calculus is called limit. I think you have heard of this. But in the real world, when we talk about speed limit as 30 km per hour or speed limit as 50 km per hour, what does it mean? It means that you can hit the point of 50 km per hour, just that you cannot exceed it. And you have interesting sayings that your limit will constantly change. This is the non-calculus. But when it comes to calculus, the meaning of limit is completely different. Like the limit of fx equals to L as x tends to c. So basically it has a different meaning, even though the word is the same, limit. So actually this adds on to further misconception by errors of analogous transfer of knowledge. So it is very interesting to take note of some of these things, especially for us as educators and researchers. And of course, one thing that is interesting to take note is that usually in school textbooks and teachers usually present the concepts in algebraic form. Downplay the importance of a relational understanding of the underlying concepts. And of course, students have difficulties with pre-calculus concepts. Why calculus is deserving so much attention? The reason is because if you look through education literature, a lot of things have been done in other topics like algebra, like geometry, but relatively little is done on calculus. And calculus is such an important topic related to STEM education. So that's why in this talk, I really push for the fact that we need to pay some attention to calculus. And as we pay attention to calculus, we can take a look at what are the things that work has been done on the other topics like algebra. Let me share with you something called a concrete pictorial abstract approach. If you go back to the learning theory of Brunner, 1966, if I'm not wrong, on the cognitive development of children, he actually proposed three modes of representation. The enactive representation, that means when you teach a concept, you let the students play with the concrete form of the objects. Iconic representation. After the students have an experience with the concrete, you can start to use pictures and symbols to use pictures of the concrete object instead. And slowly we move on to the symbolic representation. So enactive, iconic, symbolic. This is the three representation. It explains how knowledge is stored and encoded in the memory. And in fact, this is such an important approach that in the teaching of algebra, if you look through education literature, algebra, young kids start to learn algebra at the upper primary or lower secondary. There is such an approach called the concrete pictorial abstract approach in teaching algebra. If you take a look at my diagram over here, when we teach algebra to young kids, instead of getting them to start to use all the symbols X, Y, Z, and so on and so forth, we let the students to play around with the object. You see on my screen here, I hope you can see my screen. There's one box of cards. These are called LG cards. And there are circle things on the right. These are called LG discs. They let the students play with objects like what is meant by X, what is meant by X squared. How is it represented? What is represented by -1? So it becomes a concrete object that young kids can play with. So instead of starting using symbols on textbooks, they start to let students play with it. Algebra can be represented as a disc or even rectangle, like what you see on the left called LG cards. You let the students play around, they have dimension, they have the length, they have the breadth. So all this algebraic concept becomes very concrete for the students. Gradually, we move from concrete to pictorial. So instead of letting the students play around with concrete object all the time, slowly we've moved them with a seamless transition to let them see that the same object can be represented on a picture. So now on the picture, in the middle, you see here is pictorial. You can see rectangles. There are many rectangles over here. And as a result, all your algebraic formulas will start to surface. For example, A plus B times C plus D. How the expansion actually can be explained using these objects, using these pictorials. And eventually, the last step we move on is to move on to abstract. So abstract meaning that it is the typical exercises that we get the students to do in their expansion and factorization, etc. So it was proposed in the teaching of algebra that we move from this transition from concrete to pictorial to abstract. At the abstract stage, if at some point in time I forget about the formula, I have the pictorial to fall back on. Suppose I forget about what is the expansion of A plus B squared. I can have the pictorial thing to help me recall how this formula is derived. And the worst thing, if this pictorial thing doesn't make sense to me, I can still go back to the concrete. So you can see that it is a forward moving C to P to A. And when I'm lost, I can always track back from A to P, and if necessary, go back to C. So as a result, the learning of algebra using this so-called concrete pictorial abstract approach becomes something meaningful to the students. And this fits in the theme of what we call self-directed learning. Students can use this approach to discover many things using algebra. You can talk about completing squares. You can talk about even binomial theorem if you want. You can even talk about generalizing the algebraic formula. It is so powerful when young kids, they can start have things to fall back on when they are lost, and they have a method to discover so-called formula, all these formulas on their own. Instead of memorizing formulas from the textbooks, which are meaningless to them, they can start to construct meaning to what they are doing. So that's why in the teaching of topics like algebra, there is such an important approach called the concrete pictorial abstract approach, which is nothing but based on Bruner's 3 modes of representation. And if we look at this topic on calculus, if we refer to how calculus textbooks are written, one general observation is that it focuses too much on the use of mathematical symbols and equations to discuss the procedures of calculus. You talk about differentiation technique, you talk about integration technique, and actually relatively little time is allowed for students to explore graph and the real world context. So what I am really thinking is it possible to consider something of a concrete experience in calculus or even pre-calculus topics? Again, the notion of concrete in calculus has to be a bit different, has to be a bit different. In algebra, you can talk about the cards, the discs to play around. But if you talk about concrete in calculus, what exactly is meant by concrete? A lot of the things we need to reinterpret in the case of a calculus. If you talk about the rate of change, there's nothing concrete, you see, there's nothing physically they can touch. But if you look at it as an experience, they can have experienced a lot of things. When they are traveling on a car, when they are walking, when they are running, when they are speeding up, when they are involved in marathon, there are so many things that in the real world experience. So perhaps the issue of concrete in this case can be widened to mean real life experience. So some reinterpretation is needed over here. It is different from the more elementary topic like algebra, where concrete really means they are physical objects that you can touch. Here, concrete can mean the real world experience that you have, that you bring to the classroom. As an example, I always like to share with this. This is in the beginning of a textbook that I wrote. Pre-calculus topic, one of the things that is very important is called functions. Function is a very important pre-calculus concept that all calculus students need to do. But if you look at the textbooks, function is always turned into procedures. But we can have some things interesting about functions over here. If you look at my cartoons over here, for example, in a certain city or in a certain country, assuming that the language is English, okay, apologies, of course, can translate to other languages. Like sometimes on the road, you see, when you see road emergency, you call 1800 police. In English, it's POLICE. So what does this represent? Now with a mobile, you can see that this police actually represent a telephone number that's easy for people to remember. So you can let your children experience this. This is what we call concrete experience. Concrete doesn't mean really physical objects, but now in this case, it's a real world experience. In the real world, how people make use of functions to help us remember important concepts. And of course, the usual thing, we can move them on in a case of a calculator, the input-output machine, letting students play around with this and how it translates to a graph. So instead of telling the students immediate rule, what is the rule, how exactly to draw the graph, getting the students to experience a lot of this real world use of function and how eventually it is translated to an input-output machine and eventually onto a graph. I think a lot of this concrete experience is important in the teaching of calculus, which currently I find is actually something that could be lacking in our case. Not only that, if you link mathematics to physics or to science, and of course that is the whole intention. That is the whole intention. Because in STEM education, you are linking mathematics, science, technology, everything together. Okay, so one thing, a concrete.
Recording in progress.
Indeed, you really want your students to do experiment and to do the point plotting. It takes up a lot of the time. So many of the teachers, they will actually skip this and they will get the students to memorize the shape of the graph and to sketch the graph. Instead of plotting, they get students to sketch the graph. Sketching, you don't need to be so accurate. You also get the shape. It is very economical. It's very economical, but unfortunately, you take away a lot of useful learning experience from the students. So that's why this transition from plotting graph to sketching graph itself is a movement to develop in students the concrete experience that is needed before they move to things that are more abstract. They are pictorial and eventually abstract. So that's why the concrete experience part in this curve plotting is definitely essential to build up their understanding of functions and in relation to graph, which is the most important part. Which is one of the most important part in the learning of calculus. Again, another problem that I want to say is that not only the concrete part, even the pictorial part, there is very little emphasis. The Singapore calculus textbooks, I have taken a look, and a lot of focus is on the computation rather than developing the so-called concept image among the students. So instead of discussing pictorial interpretation of calculus concept, attention is very quickly switched to the algebraic method to find these entities. So in other words, most of the time, we go to the abstract part very fast, a lot of computation. As a result, a lot of these things that we learn may become meaningless to the students, which is one thing that is a little bit of a concern. Too little is invested in pictorial. I can even show you an example in a later study that I have. In our textbooks, we talk about points of infraction, stationary points, and so on and so forth. We get our students to do a lot of calculation, give them equations to calculate. And there was one question in my small case study. I have this graph. This is not a typical exam question because it is asking for concepts. It's not asking them to calculate. We give them a sketch of the graph. This is under item 9. And we ask them, how many points of infraction are there? You can read my paper. I have written this paper. This is a ZDM paper. And most of the students, if not all, were not able to recognize the number of infraction points. And they know that infraction points, they need to do d2y dx squared equal to 0, but they do not know physically how this is interpreted. That means they do not have the concept image other than the procedures of what an infraction point looks like. So this finding is a little bit shocking, as in too many of the students were not able to do that. And also, even though the students that we conducted the study, they have been using graphing calculators. Graphing calculator is a tool that we use to learn calculus. It's a very powerful tool. But unfortunately, many of them were not able to distinguish which are the points which are differentiable, which are the points which are not differentiable. We are not talking about the formal definition of differentiability. We are getting them to see this modulus function graph. Are they able to see that at the point 0, 0, the origin, the function is not differentiable? But unfortunately, many of them have difficulties with that. Maybe I show you a case how we can invest in this pictorial case in the pictorial part in the learning of calculus. Let me share another screen. Can I check with you? You can see my screen, the screen of a graph over here.
Sure.
Now I have changed to another screen. This is the screen of a graph of another graph, y equals to x squared. Are you able to see that? Sorry.
Yes, Mr. Tottenham.
Oh, thank you. Thank you. Yes, you see.
Yeah.
One thing that is really interesting when we look at graph is this. Okay, now we have technology. And this technology is really very powerful now. And in fact, you take a look, this technology is cheap. I'm actually using a copy of this Graphmatica. And Graphmatica is a freeware that I can download. And of course, if you have a mobile, you can download things like Desmos or whatever graph plotter. All these are free, I think. Yes, a lot of this technology now is not a matter of the money. In fact, they are freely available. And like, for example, you want to talk about differentiability, you want to build in the student's concept image, a lot of things can be done. You can take a look. This is a curve, not a straight line. Obviously, it's not a straight line. But if you were to zoom in, like for example, now I zoom in the point 1, 1. This is the graph of y equals x squared. I zoom in. You see, as I zoom in, do you realize I keep on zooming in? You can go on very far. You realize that at the point 1, 1 itself, it becomes almost a straight line. It becomes almost a straight line. You see? So if I get out, it becomes a curve again. So this is the property of linear, local linearity. This is an important concept of differentiability. You let the students see this, they understand things or called differentiability. You don't need to bring the university mathematics down. This is what I'm trying to say. And also another thing, let me show you another example. Many of the students or typical textbooks, they like to talk about the secant line. You see, this is the meaning. Okay, you have a secant line. You want to talk about the gradient at a point. You make one point moving closer to the other point. Yes, that is fine. And eventually the 2 points merge together until it becomes like a straight line. Then this one becomes a tangent of the curve. This is another method. Yes, of course, if you are doing a research, you can see which is an important, which is an effective method. Which is an effective method. That is really important, which is an effective method. But what I want to say is that I'm not arguing which method is good Of course, there are many research that show that favors one method over the other, but at least with the use of technology, we are able to get on to build students' pictorial understanding of an abstract mathematics concept, which I think is extremely important. Okay, so I think we have invested too little time on that. That is the reason why it is fairly difficult for students to study calculus and to see this as something that's meaningful. Okay, so what I'm trying to say is that in this concrete pictorial abstract approach, more time should be devoted with the use of technology. And now usually technology is not so much of things that's expensive, but it is a lot of things are freely available. Once you have the iPad or you have the mobile phone, yeah, or even you have the laptop. Okay, now I'm coming back to my PowerPoint screen again. I'm not sure whether are you seeing the right screen? Do you see my PowerPoint screen?
Yes, yes.
Thank you, thank you. I'm a bit worried when I use this because sometimes what you see may not be what I see. I just need to check. Apologies. You see, another part of calculus that is very interesting, you don't believe you can try it out. Suppose I get my students to do this integral. If you can see the integral on my screen, there are two ways to do this integral. One way is to use integration by parts. That is a very tedious way. This is the process. Another way is to interpret this as area under the curve. If you are able to interpret this as area under the curve, there is no much hard work. You can tell me that the answer is pi over 4. But if you were to use the process of using all the integration techniques, you will spend a long time. And eventually you will get the answer as pi over 4. So that's why when we do calculus, always important to get students to experience the pictorial part first before moving to abstract. In my own personal experience of working with students in the undergrad level and with the pre-university level, I really saw that many students, when they are presented with this question, they will immediately jump to use the integration by parts without even considering pictorial interpretation. That's because I think they do not have much opportunity to develop this pictorial part, which is an important part in the learning of calculus. So that's why all these questions, if you take a look, if you use a pictorial approach, the answer is almost immediate. But if you use the method of integration techniques, that means the abstract approach, many of them are difficult. And in fact, one part could be impossible. So that's why the CPA, before moving to abstract, the pictorial deserve a lot more time and a lot using graphical approach. And some of this you can use technology to help, which is really, really useful. And of course, one of the pitfalls of technology is it is not just a way to help us check the answer. When I saw how some teachers use it, I'm a bit disheartened, as in they use the technology to check the answer. In fact, technology actually provides a way to develop conceptual understanding or perceptual thinking, the ability to think of the mathematical concept both as a procedure and as a concept. So that's why I think technology is not just helping us get quicker answer, but it also provides the way we change the way that we think about mathematical concept. I think this is one thing that is extremely, extremely important that we are looking at. Let me do a short comparison. What is the advantage of CPA approach? Like, for example, in algebra, if you are seeing my screen over here, some children, when they talk about a plus b squared, they are always thinking of is a squared plus b squared. They forget about the plus 2ab. So how exactly to check this? If let's say they can fall back into pictorial, they have seen the cards, okay? So the plus 2AB is very naturally there. It is very natural. But unfortunately, if you do not focus so much on the pictorial part, they will not know which is the right answer. And in fact, the wrong one, that means A plus B squared equals A squared plus B squared, is the more natural answer to the students. So that's why it's always important. But unfortunately, in calculus, sometimes when I'm stuck, there's no way that I can go back. That is the whole problem there. So as a result, the whole thing becomes so abstract and so unnatural to the children. I'll give you an example. The two integration formula. If you take these two integration formula, which one is correct, which one is wrong? Of course, the first one is correct, the second one is wrong. So even at the very abstract stage, let's move on to the abstract stage, where even when I'm stuck at this, there must be a way for me to connect back to the mathematics that I know that I'm wrong. The first one is correct. The second formula below here is a generalization of the first one. If you talk to anybody, I think it's a very natural generalization. There is nothing wrong, but unfortunately, it's not the correct formula. So it is always important, even at the abstract stage, you need to link back to what is the fundamental concept. Integration as a reverse process of differentiation. You see, so lacking a lot of this connection across mathematical concepts leads to a lot of these errors. And these errors here are creative, are very creative creation by the students. You cannot say that they are bad, but they are very creative product of your students. Okay, assuming that they do not know the mathematical concept. They are very creative. Yes. I can show you an example. This concept here, this integration here. This is an authentic work for students many, many years back. This is also a very creative formula. How exactly to check that my answer is wrong? So, of course, you need to link back what is the meaning of integration? What is the pictorial value? And how to check that this answer is wrong? By using integration as the reverse process of differentiation. You can know that this is actually not correct in the first place. So that's why if you even focus on the abstractness part of the calculus, you must actually link it back to all the other related concepts and link it back to the pictorial part if necessary. So without connections across all the concepts and without connection to the pictorial part, it's very difficult to get to the right answer for this. So, in short, concrete, pictorial, abstract, the concrete part, a lot lies in the pre-calculus. The experience that the students go through about functions and graph. The pictorial part builds up the total concept image. And finally, the abstract part develops the perceptual thinking of a student. So if you base on the education literature, you can see a lot of these things are there, but just that hopefully the CPA approach can tie them up together and put it in a pictorial form. Concrete, pictorial, abstract. It is not, to me, it is not a linear sequence. It is a cycle. And each stage itself represents something. For example, concrete part reflects the experiential learning of a student. Pictorial part, the technology comes in very clearly. And perceptual thinking, actually perceptual thinking is between pictorial and abstract, not just at the pictorial. And at the abstract stage, the connections across the concepts are important. So with this, I will want to quickly summarize up. I think my time is up, right? I'm not sure I might have spent too much time. So many papers have been published on the teaching of calculus. So the proposal of this CPA approach is an effort to pull together this research work that has been conducted. And in fact, the technology, if you look at some of the education paper on the use of technology, they are as early as the 1980s. And they are not just the recent paper. They are as early as 1980s. Many of these papers are available. I think it is time now for us to rethink how technology can play an important part to enhance our learning of calculus and, of course, mathematics at large. Okay, so I guess with this, I will end my session here. Thank you so much.
Thank you so much, Mr. Tosunam, PhD. It's really prominent for us to believe that we believe that mathematics is working object is abstract, right, Mr. Tosunam? So that's why by using the CPA, we believe that it can enable and help the students to understand deeper and deeper and comprehensively, especially to calculus that, well, frankly say that most students, especially for the pre-university student, they believe that calculus is kind of spectre, kind of spectre, frightening spectre for them. But with your presentations, it is really enlighten us as the educators and the lecturers of mathematics education and mathematics itself, that well, actually calculus itself should be supported by picture so that they can achieve their knowledge. Thank you very much.
Thank you,
Mr. Tosunam. Okay, for ladies and gentlemen, just to remind that all the questions, you may drop your questions to the chat box if you have some, and as what I wrote on the text box. I think there are some questions. Okay, the question will be read after all the panelists have presented their presentation. So the next presenters will be Dr. Sulyadi. Hello, Dr. Sulyadi. How are you?
Fine, thank you.
It's been a long time no see you, right? Okay.
Sure.
Dr. Suryadi, you have 30 minutes to present your materials and present your presentation. So the time is yours, please, Dr. Suryadi.
All right, thank you. Let me share the screen first. Can everyone see the screen?
Yeah. I can see your screen.
Okay. Should be like slideshow. All right. Can I just move it around? Yeah, should be here. All right. Okay, Assalamualaikum. Very good morning to everyone. First of all, I'd like to say thank you so much to University Muhammadiyah Surakarta for the invitation. I'd just like to appreciate the invitation for the talk today. Thank you so much once again. All right, my name is TS Dr. Sulyadi Firdaus Sufahani. Normally, my students just call me Cik Su because it sounds cute. All right. And the title of my presentation today is the Malaysian Secondary School Menu Planning System with Post-Optimality Process. All right. So we're going to discuss about the application of mathematics in the real world problem. So in this case, for the Malaysian secondary school, which is something to do with the education itself. All right. All right. So first of all, welcome to the conference. All right. So we have the prestigious speakers, as you can see here. And let me introduce a little bit regarding myself. So I'm the head department of Empowerment Student Challenge at Universitas Nasional Malaysia. I'm also the senior lecturer of the Faculty of Applied Sciences and Technology. At the moment, I'm the principal researcher of the Overseas Integrated Research Group under the Institute of Integrated Engineering. And my interest is more on the operational research, optimization, medical statistics, mathematics, data analysis, and so on. All right. I had my first education for the secondary school at the Sekolah Menengah Abdullah Mushi, Pulau Pinang. All right. And then I had my first degree from the University Utara Malaysia. And then I had my master's from the University of Nottingham. And then I had my PhD. It's a training program from University of Sheffield and also University Technology Malaysia. Because I'm really interested in computing in innovation competition. So far, with the knowledge that I had in terms of education, where I like to apply it in real problems, so I managed to compete like with 96 projects internationally and nationally. All right, and I managed to win like 22 best award, 61 gold award, silver award, bronze, and also through my innovation and research, I managed to produce 2 patents and also 58 copyright. All right, this is some of the competition I managed to compete. Some of it in Thailand, some of it in Korea, Malaysia, mostly national, also international competition. All right, before I start with the presentation, hopefully I'd just like to show you a short clips, try to give you an idea regarding my research. Hopefully you can hear the sound, hopefully. Okay, hi everyone. My name is Technologist Dr. Firdaus Suhani. Before we start the presentation, I'd just like to show you a short clips, try to give you an idea regarding my research. And I'm about to have my lunch. Is it healthy?
Young man, what exactly are you doing? I'm balancing my diet. A balanced diet means eating a variety of foods that promote health. Lots of grains, bread, rice, noodles, plenty of fruits and veggies, some meat, some milk, and even an occasional little treat. Oh, now I'm catching on. So keep it all in balance and watch what you eat. School lunches, smart yet satisfying. Pardon me.
All right, then. Probably you already listened to the short clips. All right, so I'm dealing with a school menu, all right, in Malaysia, but in order to solve the problem with the school menu, I'm using a mathematical model, all right, where we call it as a either you like to use integer programming, linear programming, or operational research. All right, so we try to use the concept of mathematics and try to solve a real world problem. Okay, normally we do have like a lot of cases involved of people will think that, oh, okay, mathematics, how are we going to apply mathematics in a real problem in terms of education, so any related things. But in this case, we know that we can use mathematics in order to solve real problems. So now in Malaysia, the nutritionists are responsible to plan a menu based on the recommended daily allowance, or we call it as RDA, for the secondary boarding school. However, there's no specific calculation for the system, all right, that being built. So this is a very good motivation for us to solve the problem. Okay. Now, normally they provide 6 meals per day, which is non-selective. The caterer are given a certain budget for the school children, which is 15 ringgit per student per day. All right. And then we have various Malaysian recipes, so it's a bit hard for us to choose the best one. So which one is good for the children? Sometimes the combination of the food might exceed the RDA, or vice versa. All right. So the 6 meal that I mentioned just now is breakfast, morning tea, lunch, evening tea, dinner, and supper. All right. So now in Malaysia and even in the world, there's a lot of problems actually. This is the problem that we had in Malaysia and also in the world right now. So for example, for the manual selections, all right. So the nutritionists, they are using a certain method where we call it as a matchbox method. So they take a little bit of rice, a little bit of chicken, for example, a little bit of vegetable, and they say, okay, that's it. That's probably enough for the nutrient and so on. So it's not like a accurate measurement. So we should use mathematics in order to calculate all the nutrients and all the boundaries. Moreover, they're using all the budgets. They're not going to minimize the budget, and each nutrient has a lower bound and upper bound. So and then variety. Normally they serve same food every day. Right, time consuming, because normally nutritionists take like more than I don't know, probably an hour or two to like 24 hours in order to come up with just a simple menu. All right, by using mathematics and some computer technique, we can just produce with like 1 week menu within a second. That's really interesting actually. All right, and they don't know about computer programming, about the flexibility. Normally, whatever food that being served, the student have to eat the food, so they cannot change the food. Even the user cannot change the food. So this is a lot of problem that occur in Malaysia and also in the world. So we need to tackle this kind of problem by using a mathematical approach. So people will think that, oh, I don't know. I never heard that we can produce a complete menu by using mathematics. So this is something interesting for you. All right. So this is a research question. All right. What are the suitable menu that can be prepared within the limited budget? Does this menu cover the entire nutritional requirement? Will this menu meet the preference of the customer? Can there be a variety of food? Is it possible to solve problem that more than 400 variables, more than 40 constraints, and more than 400 parameters at the same time? Okay. Can the process time be reduced? Can the problem be solved simultaneously on different objectives? And can the user change their menu or choose the food at the beginning or at the ending of the process? So there's a lot of research questions that appear in this kind of problem. So in order to answer all the questions, so this is our research objective: to establish the current state of menu planning in Malaysia secondary boarding school. And it's not about Malaysia actually. You can apply it for the other country as well. Because I'm using a database from Malaysia, the Malaysian food. And then normally like Malaysia, Indonesia, and in Singapore, we kind of have a similar food. So there's nothing wrong with it. We can apply the same thing. Same goes for Brunei. For example, probably like in China, for example, probably they have different kind of food. So we can just replace the food in the database and people can use it. Nothing wrong with it. Okay, the second one is to develop mathematical model and a new algorithm for menu planning. Okay, to develop new binary programming model that satisfy all the requirements, to implement post-optimality process in the menu planning problem and develop new planning system, and to develop addition support system. So in this case, we are using a mathematical modeling, right, with a new algorithm, for example, and also we're going to implement some of the computer technique in order to come up with the addition support system. All right, this is a scope and limitation, right, before we go on with the mathematical part. So the data for the Malaysian menu and its nutritional value are taken from the Malaysian Ministry of Health and also the book called Nutrient Comparison of Malaysian Food. All right. And then the list of meal and price used in this research were taken from 3 different states, which is in Kuala Lumpur, Penang, which is my hometown, and Johor is where I'm working right now. And then there are 11 types of nutrient and 10 food groups that consider in this research. You should know that for the secondary school children, which is from age 13 to 18, normally the best nutrient that they need to consider is this 11 type of nutrient. You need to refer it to the dietitian or nutritionist to know which nutrients are good for this kind of age category. And then we have 10 types of food group. This is common, general, that been used for every type of age category. All right, and then this is the data. Okay, for the primary data, we get it from the interview and questionnaire, which is from the food price, meal structure with food groups, menu list, daily budget, and nutrient list. Okay, so this is the meal structure. What sort of things that you need to eat during the breakfast? Which is beverages, which is drink, and cereal flour base, food that been made by cereal flour base. And for morning tea, you need to have beverages, which is a drink, and rice flour base, a food that been made by rice flour base. So this is the meal structure that we implement actually in Malaysia. I think so. It should be the same thing in Indonesia and also Singapore. All right. So this is the database. I'm going to show you afterwards. It's quite huge actually. For the secondary data, all right, we have the nutrient boundaries. So As you can see here, this is the nutrient boundaries for energy itself. So the lower bound is 2050. If I'm not mistaken, is kilojoule. All right. And also the upper bound is 2140. Means that if let's say you eat less than 2050, it will be lack of nutrient. If let's say you eat more than 2840, it will be like poisonous for you, because actually nutrient, there's a certain boundaries for it. You can't simply eat uh, anything like by yourself. So you have to refer to a certain boundary. People will think that, all right, then for you to look nice, for you to look fair, you have to eat a lot of vitamin C and so on. But actually, as you can see here, there's a boundaries for it, which is 65 milligram per day at least, and at most is 1,800 milligram of vitamin C. So if let's say you take more than that, probably it's going to be poison for you. You might probably people think that, oh, I like to look beautiful, I should take a lot of vitamin C. Now guys, please remember there's a certain boundaries for each nutrient. All right, this is very important. This is how mathematics play a major part in your healthy life. Okay, there should be a boundaries that you have to know about it. All right, and then we have the nutrient content for each food, the one that the database there, and I'm going to show it to you afterwards. Then we have the addition variable. Addition variable is the food, actually, the food variable. As you can see here, this is the addition variable. We have beverages. So far we have 37 type of drink, so we have to choose the best one. Cereal flour base, we have around 50 cereal flour base type of food, so we have to choose the best one once again. And this is the meal structure that we have to calculate in a day. For example, we need 6, because we are serving 18 dishes per day. So we need 6 drinks, 1 cereal flour base, 1 rice flour base, 2 cereal meal base. This is, for example, like rice, plain rice, chicken rice, just the rice itself. Noodles, for example, it's belong to the cereal meal base category, and so on. So we have to refer to this one. So actually people will think, how do you come up with this one? As I mentioned earlier, I already showed it to you. These are the meal base. So we have 1, 2, 3, 4, 5, 6 beverages. Same goes for this one. That's why I said beverages, I need 6, including 2 plain water. All right. And same goes for the others. Now, in our database just now, as I mentioned earlier, beverages, we have 37 beverages, 37 type of drinks. Cereal flour base, we have 48 type of cereal flour base. Rice flour base, we have 38, and so on. So our addition variable, or our variable itself, we have 426 variable. Can you imagine? We have 426 variable, and we need to choose 18, which is the best one to serve in a day. All right, so can you imagine that? It will be like a part of the MP heart problem, right? So it's kind of complicated, but it's okay. We can just solve it by using mathematical approach. So nothing to worry about it. All right. So I still remember when I went to see the dietitian and I said, okay, I got a problem. So I need to solve for the secondary school children to come up the best menu. Can I know the boundaries for each nutrient and so on? And I still remember the dietitian said, okay, we don't have like a accurate calculation for the boundaries, but you can refer to this certain book, and it suggests you a certain boundaries, and you can use a mathematical approach to solve it. So we don't have that kind of expertise. So probably you, from your part as a mathematician, you can solve it. And I mean, from there, we come up with this kind of solution. All right, for the objective function itself, okay, we try to minimize the budget for the government. As I mentioned earlier, we are given like 15 ringgit per day. Okay, 15 ringgit per day. And then it cover up all the 6 meal, as I mentioned earlier, from breakfast until supper. So you need to spend that 15 ringgit to come up with 6 meal. So some of people say 15 ringgit for 6 meal. Are you out of your mind? Because I mean, some people just spend like 10 ringgit for just for lunch. Now you got like 15 ringgit for 6 meal. Can you do that? And the answer is yes. All right. So I'm going to show it to you afterwards. So these are the objective function is to minimize the budget, and the constraint is the value of neutron element cannot exceed or exceed less than or the boundaries of the each nutrient. Remember that there's a upper bound, so we cannot the food cannot be less than the lower bound and cannot be more than the upper bound. Okay, and then the food requirement for each day. Remember that I mentioned that we need 6 drinks per day, 1 cereal flour base, and so on. And then each type of recipe is allowed to come out once, not more than A, except for plain waters and plain rice, because in Malaysia, we normally eat 2 times for the plain rice during the lunch and also during the dinner. Same goes for the plain water during the lunch and also during the dinner. So each type of food need to come out at least one, at most one, except for a certain food that I mentioned earlier. All right, this is the I tried to make it to general mathematical problem model, as you can see here. So solving 2 type of set, which the first one is small data, which is only have 10 variable. So in this kind of data set, we try to take like 10 type of food, different food from 10 food groups. That's why we have 100, and 426 is the complete database. So let me show you the formulation actually. This is the formulation. I try to make it as simply that I can, all right? So this is try to minimize the cost, all right? So this is for the big data set. This is for the small data set. And this is the constraint for the nutrient itself, all right? Can you imagine we have 426 food here. So we have 426 category for the energy itself, all right? Same goes for protein and so on. And then we have the food group requirement. As I mentioned earlier, we have beverages, 2 beverages including 2 plain water and so on. And then we have the meal structure. We have to arrange the meal structure based on the mathematical model, as I mentioned earlier. So meal structure, for breakfast, we need beverages and cereal flour base, right? And then you have the variety requirement itself. So variety requirement, as I mentioned earlier, for beverages we have 6 beverages. Cereal flour base we have 1. Vegetable we have 2. Fruit we have 2. Means that we need to organize and we need to serve more per day. All right. And then we have the primary division. We have 426 variable, where we can either set it as 0 to 1 or 0 to 2. 0 to 1 means that it can appear only once in a day, right? Only once, or even in a week it can only appear once. So that's why we have 0, 1 or binary. If let's say we set up the parameter as 0 to 2, means that it can appear 2 in a day or in a week, or it can appear either 0, 1 or 2. All right. So this is the mathematical modeling. Actually, if you put it in the programming, it's going to be a huge mathematical modeling actually. All right. So, but this is the simplest that I can manage to do it. All right. Now, come back to the slides. All right. Hopefully, everyone can see the slides. All right, because I just move it to a PDF version and then come back to the PowerPoint. Dr. Nafa, can you see the slides?
The slide I think is still the same. But methods and description, is it your slide that you made?
Yeah. Okay. All right. Thank you. All right. Now, so this is the database that I mentioned earlier. Can you imagine we have? Sorry, it's not 24. Sorry, there's a typo. It's not 246. It's 426 times 12. Right? We have a huge metric here. 426 times 12. 426 is the type of food. All right, can you see there? The first one is soya bean milk. How many energy inside soya bean? How many fat there inside soya bean? And how about protein? Vitamin B2, vitamin B1, niacin. All right, and then we have calcium, vitamin C, we have iron, we have vitamin A, carbohydrate, and the cost. Can you imagine that? So each type of food, we have the number of nutrient, the value of energy, fat, and so on. I can say that some of the food probably doesn't have any nutrient. For example, that we can see in the green side, right? Like jelly, honeydew, for example. So they don't have these vitamin C inside. Okay, so we are lucky. Some of the food might consist of all the nutrient, but some of the food probably only consists only part of the nutrient. But it's okay then, as long as we can capture the value of nutrient for each food. All right, so that's the database. So in this database, you can change it to your own home country. For example, you're from China, for example. So there's a lot of Chinese food that you can put inside the database. It's just a matter of changing the database, but the sequence or the coding itself in order to solve the problem is still the same. So it means that you just change the database and you can just simply run it. Nothing wrong with that. Okay. All right. This is the model approach. I use different type of model approach. I use linear programming and integer programming. All right, to solve the problem. So for linear programming, I'm using simplex method. For integer programming, I'm using branch and bound method. All right. So I'm using LPsolve, MATLAB, and AMPL in order to solve the problem for the data, small and big data sets. And then I'm using the binary programming. So for binary programming, we have two types of approach, which is the modified Ballas algorithm. Okay. And also we have the extended binary algorithm. Normally for modified Ballas algorithm, the method was introduced by Ballas, all right, and then he tried to solve these a simple binary programming by using a hand calculations, right? Because he's not using any simplex method, he's not using dual simplex method or branch and bound method. It's just by using a simple Ballas algorithm, and for the hand calculation itself, you can solve the problem until 60, if I'm not mistaken, 60 variable, right? But in my case, the smallest number of variable is 100, so I have to convert from hand calculation into a computerized calculation. So that's the first step. Then we have the extended binary programming. Okay, this is by using branch and bound method. Okay, all right. So what we call it, tested and been proved, saying that branch and bound method is the best method for solving a large 0 and 1 problem. Okay, so this is the algorithm itself, Ballas algorithm. And then we have this is the one that I produced by myself. I call it as delete reshuffle algorithm. Okay, it's just an extend from the binary programming, extended binary programming, the one that we had here. All right, just an extension to it. But delete reshuffle algorithm means that we try to produce for 7 days menu with a single run. You just click run and it come out with 7 days menu. Okay, and each day it serves different food except for plain waters and plain rice. So we make a looping process in the mathematical modeling. So we eliminate every food that been served in day 1. For example, when you run the program, it calculates the food that you need to choose for day 1, all right? And then before it starts to run for day 2, it will eliminate all the food that been served in the database, and then it will run for this second day, all right? So that's why we call it as delete reshuffle algorithm. So this is the first, this is my algorithm, and I produced it first. And then I said, okay, my another objective is that I mentioned earlier, I want the user to change the food, even after the optimal solution has been found, right? But probably you say that, okay, I know this food is very good and very healthy, but it doesn't suit my preference. probably this food is not suitable for me. I don't like bananas, right? But the system shows that I need to eat banana. Then it's okay. Even though after the optimal solution has been found, we can change the menu. That's why I come up with a new algorithm. I call it as delete, reshuffle, re-optimize algorithm. Means that still have the same features as before, but there's an additional features where even after the optimal solution has been found, the user can change the menu and there will be a recalculation process. This is what we call as a post-optimality process. All right. If you learn about the mathematical modeling in the operational research or even in the integer programming or binary programming, linear programming itself, there's one part that we call as a post-optimality process. Post-optimality means that if you like to make a certain changes, is there any? If let's say you like to make a certain changes to the optimal solution, is there any effect that will happen? All right, so that's what we call a post-optimality process. And then after the second algorithm, I was thinking that okay, so I managed to serve different type of food daily, and then I can change the food at the end of the program. But how about if let's say I can choose the food in the beginning of the program, right? And I run it, I got a certain solution, but still, let's say it doesn't satisfy me, I can change the food. So I come up with a new algorithm, this is one, the final one, we call it as a Subhani-Ismail algorithm. All right. Now, everyone, as you can see, I'm talking about the algorithm itself, but actually, the story behind it is by using a mathematical modeling, mathematical approach. This is just a pseudocode, all right, in terms of algorithm, what sort of step you have to use. But in order to solve the steps, you have to use mathematical programming. Okay, so this one where I can say that the user can choose the food, all right, up to 3 days. Okay, they can choose the food manually, then run it up to 3 days. Okay, if let's say more than 3 days, you can just use the automatical selection, which is 7 days. All right, where you consider the whole food, then you can change it. This is what we call Subhani-Ismail algorithm. All right, so based on the solution, okay, I'm so sorry if let's say I go a bit fast because I just been given like 30 to 45 minutes. All right, so if let's say you have a lot of you have questions, just put it in the chat box and answer it afterwards. All right, thank you. Now, this one is the solution for the linear programming and integer programming. All right, as you can see here, if let's say using linear programming, I know we have to serve 18 type of food daily. All right, but the result doesn't make sense at all. For example, okay, like the average orange flavor drink, we have to serve it twice in a day. But the milk, UHT low fat, we have to serve like 0.8. So it doesn't make sense, right? Compared to the integer programming. So there's some rounded up process that happening for the integer programming. Because you know integer programming, you can solve it by using branch and bound, you can solve it by using cutting clean and so on. But the basic concept behind integer programming is the linear programming. So the problem being solved by linear programming, and then we use a certain extension in order to solve it as an integer programming. Okay. Now for integer programming, it's very obvious. We need to drink orange flavor drink like twice in a day. UHT milk is just once in a day. Plain water twice in a day, and syrup rose drink is just once in a day. It makes sense. All right. So this is for the small data. All right. I say here small data. How about big data here? Same things goes, all right? If let's say you solve it by using linear programming, some of the solutions are in partials, okay, fractional numbers with decimal places. But compared to integer programming, it does make sense, all right? So can you imagine around if let's say you're using the big model, the whole database? Remember that I mentioned to you earlier, the government only gives us 15 ringgit per day for 6 meal. And some people think that it's crazy. You know, 15 ringgit for 6 meal in a day. But as I mentioned earlier, yes, we can do it. as you can see, for 6 meal in a day, you only spend 540 cents, which is like what? A quarter, can I say like 1/3 of the given budget. It's 1/3 of the given budget. We're saving a lot of money here. Actually, this is about school, all right? School. Normally, school caterer, they bought all the stuff in box, right? So that's why the price is quite cheaper compared that you eat in a restaurant. Okay, so that's why I can say that it's possible for us to serve 6 meal in a day, which is less than 50 ringgit. So we already proven that by using mathematical approach. All right. So now, and then I was thinking that, okay, it says here, I need to drink coconut water twice in a day. How about I like to maximize the variety of the food, saying that I only like to drink 1 coconut water in a day, and probably there will be a different drink that I need to drink in a day compared to like twice coconut, two times coconut drink in a day, right? From there, I expand it to
5 minutes remaining, Dr. Sladi.
Sorry?
5 minutes remaining.
Wow. I don't know. There's still like 40 slides to go. All right.
Wow.
But it's okay. Try to go it a bit fast. So, so as mentioned earlier, try to make it more interesting. Serve different type of food daily. So I'm using integer programming. All right. So this is the solution. So I have to go a bit fast. All right. So this is the nutrient boundaries that I managed to produce each day, which is within the upper bound and lower bound. All right. So from there, I try to come up with the programming. All right. So the system will produce 7 days menu with all the advantages that you can see here. All right. So this is the menu that I managed to produce in 7 days. Can you imagine I save 50% from the budget daily, and then within a year, I managed to help the government to save more than $250 million per year. Can you imagine that? We are not talking about million here, we're talking about billion within a year. Okay, so this is the post-operative process where you can make some changes and it'll be the calculation process. So this is the program itself. Okay, this is the copyright. I'm just going to go very fast. All right, this is the pattern that we managed to do it. I managed to won the award. So through the program, I managed to win a few awards. All right. This is from the Bangkok and also USA. All right. This is the best award from the WIPA, Thailand. And this is some of the double gold award and so on. This is the best award and gold, singles best award, gold award, some of it. All right. And this is the gold award in UTM. And this is the best platinum award and gold best product. This is in MTE, Malaysia. This is in Thailand itself. This is in Korea, won gold award. This is in iTech, some of it. All right, this is from India itself, some award. Okay. Yeah, this is I made some collaboration with the hospital for it. Test run, some knowledge sharing with the dietitian, with the school, with some of the villages. This is with the minister, and this is with the Brunei, Singapore, and then this is Indonesia. This is UAD. Through this one, I managed to publish more than 19 papers. I extend the research to myopia, blood pressure patient, eczema, autism children, breast cancer patient, stroke, diabetes, some sinus, and also for the TAFE school. All right. Just try to go a bit fast. Seems to be that there's no competitor in the world. We are the first one to produce for the school children, also for the related diseases. And we have some local industrial partner from here. All right. We are selling the software from mathematics approach. We come up with a product. Imagine that from mathematics we can come up with a product. All right, this application itself. This is the system. All right. Just show it a few seconds. Okay, where it can run and produce the menu, make some changes and so on. Okay, now if let's say you are not satisfied, you can change the menu and then there will be recalculation process. All right, check if let's say, okay, this means that the constraint is okay. Now it says that energy criteria doesn't meet, then you need to change your new food and so on. All right. So this is the basic idea of the program. Sorry, I have to go a bit fast. So this is the advantages that we can gain through the product, which is as I mentioned earlier, from the mathematical problem, so you can come up with a product. So this is the novelty and usefulness of the applications. And this is the environmental friendliness. We try to minimize the food. We try to prevent any serious illness and so on. All right, thank you so much, Dr. Naufa. Hopefully, I didn't exceed any time and I don't want to disturb the next presenter. Sorry once again.
Thank you very much, Dr. Sladi. Your presentation helps people like me that who has a problem with obesity, I think.
Yeah, and I'm suffering from obesity as well. So
okay, so high five.
Yeah, because we are working from home, right? So yeah. The only thing that we can do is just do our work, eat and sleep and so on. So I'm suffering from that kind of problem.
So let's if we take your research into the topic of the theme of the conference, this is the concrete examples on how mathematics become a solutions on many problem. In this case, is about nutrient of choosing the menu, food menu, and I believe that your findings helps many people to make their life become fit enough for their become healthier.
It's true. It's
right.
True. Yes. Yeah, that's why that's our aim actually. We try to help people, you know, because probably there's certain things that we can use mathematics in order to solve other people's problem. And in this case, we're trying to solve in terms of health, right? So hopefully it will benefit to everyone.
Okay, thank you, Dr. Suliadi. And ladies and gentlemen, for the next speaker will be Professor Dr. Sutama MPD from Universitas Muhammadiyah Surakarta. As what I told, as I mentioned earlier, that Professor Dr. Sutama have a double agenda for today. He have to manage for the graduation session in our university in UMS, so that's why he sent us the video. So the committee already. Okay, the committee is ready to play the video. Please enjoy the presentation of by Professor Dr. Sutama MPD.
Assalamualaikum warahmatullahi wabarakatuh. Thank you everyone. Today, I will talk about my research that has entitled Collaborative Mathematics Learning Model for the COVID-19 pandemic era, especially in middle school student independent habitation, where we must discuss about collaborative learning that for pandemic era. Firstly, we know that teachers' attention has been drawn to the topic of learning model and independent as a result of the global COVID-19 outbreak. Teachers have a critical role in encouraging student independent and selecting learning model. Teachers' perspective and action will determine as learning model change in the COVID-19 pandemic era. Learning model can be one of the social factor that interacts to establish, design, and guide the life of future intelligence, creative, innovative, and independent student. And the N indicates that the teachers works out culture both as statement and action should encourage to student to be independent. So independent era of the COVID-19 pandemic, a solid commitment by teachers in learning mathematics is needs to prepare students to become independent both from the teachers themselves and from policymakers. The teachers' commitment push forward of collaborative culture and the principle of kindness. Mathematics learning in the era of the COVID-19 pandemics will be of high quality through of practical combination of action and reflection. To realize such learning, alternative solution that can be offered are collaborative based innovation in learning mathematics in the era of the COVID-19 pandemic. This learning innovation allowed the creation of independent study student. For now, about the effective collaborative based model for managing mathematics learning in the era of the COVID-19 pandemics to encourage learning about we must know about two aspects. That is learning mathematics in the era of the COVID-19 pandemic, which is collaborative based and evaluation of independent students. In my research, I use qualitative research and ethnographic design. The research subject in the article of school principal, mathematics teachers, and grade 9 student of SMP Negeri 1 Colomadu Karanganyar. Data collection that is used as observation and field notes, interview, and documentation. So triangulation was carried out to test the credibility of the data. The data analysis technique as the study was carried out inductively. The collaborative-based mathematics learning management model in COVID-19 pandemic era is carried out focused on collaboration. It is done through three styles: introduction, conditioning, appreciation, motivation, and delivery of learning objective and process. Main activity, integrating scientific approach, strategy, methods, and learning media. And closing, reflection, conclusion, post-test, and follow-up. Paradigma collaborative-based mathematics learning. The great task of learning mathematics in collaboration based of the COVID-19 pandemic era is to improve the character and build in the children character. The implication of learning mathematics can creative, intelligent, creative, innovative, and interventive life. The success case can see talks, reflection, student belief in themselves, and through action, student acts of their own way. Student success in learning mathematics in the era of the COVID-19 pandemic based on collaborative is the shared responsibility and teachers and parents. We can see from the example. I have one close staff And how I know about tough heights. The radius of the base of the tuft and the radius of the top of the tuft. All this question and reflection form in the mathematics learning. Reflection in learning mathematics in the era of the COVID-19 pandemic based on the collaboration and often interpreted as a reflecting on the things that have been done relative to the following thing. Such as 1. Which ones are appropriate? 2. Which one are not appropriate? 3. What cause have not been implemented? And 4. Alternative following action to be applied. Appropriate. Reflection is functioning of an awareness of students who are silent, so that student takes action. Dialogues is one of the learning methods used to humanize human. The use of dialogue in learning is a democratic process and respects student experience. In the COVID-19 pandemic era, student worksheet was used in collaboration-based mathematics learning to familiarize students with independent study in order to achieve optimal student achievement. Worksheets were designed to find concept, join problem solving, and problem solving independence by completing the answer for each of this process. The learning process based on collaborative is carried out authentically. Assessment of mathematics learning outcome is associated with character quality, mastery of numeracy, literacy, and developing higher order thinking process. The image of mathematics teachers in collaborative-based learning in the COVID-19 pandemic era is able to bring a resolution. Before learning, the teachers guides in familiarizing students with finding mathematical concept independently with the help of worksheet. Collaboration-based learning in the era of the COVID-19 pandemic was carried out by accustoning students to the thing independently and regulates themselves rather than relying on others. According to the result of online observation, the collaborative-based learning of mathematics in COVID-19 pandemic era emphasizes the importance of preserving human existence in the sense of having human to be more humanist, more culture, as both human being to develop. The learning process is contributory important to balance the individuality aspect to the social aspect as a community together. In the era of the COVID-19 pandemics, a new paradigm in collaborative-based mathematics learning, student activity contracts meaning. Teacher as facilitator with student discover concept, teacher support problem solving. The mindset is a change of reflection and action to grow and develop student independence personality. The management model was carried out through 3 stages of introduction for activity and closing with 5 conditions. 1, implementation of learning method. 2, the management of study group and media. 3, the management of teaching material. 4, multi-directional interaction management, and 5, management of authentic assessment. In preparing independent students, mathematics teachers are required to be wise and challenging. It is founded on the firm religious, basic character, social character, character appreciating order, and having the potential to be intelligent, creative, innovative, and entrepreneurship in preparing independent students. Okay, that is my presentation about collaborative mathematics learning model for the COVID-19 pandemic era, especially in the middle school student independent habituation. If you have any question, please let's use discuss together. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Professor Dr. Sutama. Your absence still be here. Okay, ladies and gentlemen, the audience, we're finally stepping to the question and answers session. So it will divide it into 2 terms, which is can be consists of 3 questions. So before well, actually there are some audience that already dropped the questions to the chat box and already answered by Mr. Tohtin Lam. And before that, I request for Mr. Tohtin Lam to elaborate more about the questions that has been addressed by some presenters, some audience. For instance, we have Pak Murdayanto Barumbun, Mr. Murdayanto Barumbun from Universitas Borneo Tarakan. The point of the question is that when is the appropriate time? When is the appropriate time for us teacher to use technology to teach mathematics? Because we found that many students rely on the technology. We can't deny that. Yes. We also find it in many schools, elementary school, and so on.
Yes. Sorry, can I go ahead and elaborate?
Yeah. You can go elaborate.
Okay, thank you. Yes, because now it is not okay. I hope you can hear me.
Yeah, sure.
Yes, actually, with technology, I think a very interesting phenomenon occurs, at least what I see, not based on research data, but based on what I see in the Singapore context. Many young kids, they start to play with technology. For example, many young kids start to use Desmo, start to download a lot of funny things into their mobile, and they start to play about it. The person who are more uncomfortable with all this technology are not the kids, are not the children, but are more with the teachers. So I think this is a greatest thing that we find. So that's why in a professional development course that we get with the teachers, we are trying to convince them to buy in. And instead of getting the kids to explore on their own and learn all the wrong things, the teachers should know how to capitalize on what the students have access to and make this into a good learning opportunity. So I think when it comes to technology, a lot of the problems is not so much with the students, but more with convincing the teachers to buy in. But this younger generation of students this younger generation of teachers doesn't seem to have so much problems. Yes. So I think it's more of convincing the teachers and how to harness on this technology to enhance their teaching. So this is one point that I want to mention. So we have a lot of professional development courses in Singapore that we get the teachers to use technology. How do you teach algebra? How do you teach calculus? And I think these are very essential. If we can plug this under the whole sound learning theory framework, I think that will actually bring it to the next level. And like what I mentioned, technology should not just be used to check the correctness of the answer or just to check that the answer is correct. Or the worst thing is to take away what the students need to do. For example, many teachers are very worried. I think just now there was one question in the chat. I believe I did try to say something about it. Many teachers are very worried that technology will take away the thinking of the students. If a teacher knows how to incorporate technology, for example, how to use even a simple calculator to do problem solving, to look for patterns, instead of just getting it to help them get the correct answer, I think it will affect the students. It is developing the habits among the students. How you do with technology. This is one thing. The other question that I was addressing halfway, was that in my talk just now, I talked about calculus, and I think certain words in the real world and in the mathematics world are different. In particular, the word called limit. In mathematics, in calculus in particular, the word limit is different from the real world context. Like for example, I show in my lecture, the speed limit is, let's say, 80 kilometers per hour. Definitely, it means that the car on the expressway can go up to 80 kilometers per hour, can hit up to that. But in the case of the limit in calculus, it may or may not reach 80. You see, if the limit is 80, there may always be a distance apart. So there are some differences that I want to mention over here. So when you want to talk about mathematics in the real world, nowadays we are always talking about mathematics in the real world, mathematical modeling. So we need to be very careful with the use of the words. And many of these things, technology will help to address some of the nuances and the differences in the different usage. Yes, so I think these are the two things that I would want to address from the chat. Okay, I will pass on to the MC. Sorry.
Good. Thank you, Mr. Sultan, for the elaborations. We believe that well, actually, because the technology itself become a very, very sensitive issue, since there are some people that believe technology will lessen the cognitive ability.
Yes.
However, they also believe that with technology, it can increase the speed of understanding the material. However, we as a teacher have to be wise enough on how we use technology to at least strengthen the way we teach the students, right?
Yes.
I found research that actually technology can be given to students as an incentive. For instance, when the students are ensured that they already understand about the concept, so the technology can come in and can be tools for them to be enriched by the teacher to enrich the student understanding by using the technology. Because, well, when I was in elementary school, Mr. Tohtinlam, my teacher prohibited me to use to solve these problems. So we as a lecturer and as a teacher, we cannot spirit the students with technology. We cannot hamper the student with the technology, because they will use in the future. What do you think?
Yes, actually the worst thing is when we stop them from using the technology. This generation is very different. They will actually explore on their own. They will not stop just because you ask them not to use. And the worst thing is when they learn on their own, they may learn all the wrong things. So this is one of the problems that I see. So rather than fighting a losing battle with them, why not try to win them over and then show them what actually technology can be used? Develop the habit in them on how to use technology to develop the higher order thinking and not just the low level checking of answers. Yes, I think teachers can do a lot more in this aspect.
Sure.
Yes.
Doctor, okay, so ladies and gentlemen, do you have any question that won't be addressed to our speaker? But unfortunately, Professor Sutama cannot join with us today. So we have Prof. Dr. Lam and Dr. Sulyadi Firdaus. So anyone can want to address questions, you can open your camera on, you can drop in on the chat box, please. Anyone? Anyone? Okay, Mr. Tottenham, yes. And Dr. Sulyadi, Dr. Sulyadi, you with us? Are you with us today?
Yes, I'm here.
Okay, I thought you already leave. Do you still have time?
Yeah, sure. Go ahead.
Okay, so while waiting for the other audience to give the questions, so we still have time to have a question answer, but to fill in to make it live. So I have a question for you, Dr. Sulyadi. What's the thing that can make you believe that your research is important? How do you think that your research is important for the people? At the very first time you think, oh, I need to study this topic because it's important, especially your expertise in applied mathematics. How did you connect applied mathematics and food, let's say, or menu or choosing menu for me as the reader to lessen my fat? Dr. Sulyadi.
Okay, now, so thank you so much for the question. Let me bring you back to the chronology how I'm going to start with the research. I got the idea for the research now. All right, so because most of my, because I like to deal with the schools and also the school authorities and also with the government regarding the project and all activities. So one day we kind of have a simple discussion about the well-being of the student itself. All right. So some people ask me, you as a academician, what sort of things that you can provide or you can try to help the students or even the society in order to help them to improve their health and also their kind of life, right? So from there, I got the idea. I said, okay, because nowadays most of the students have some difficulties in terms of taking care of themselves, and then probably the school authorities, they don't have any idea how to solve this kind of problem. So so it's kind of motivate me to come up with this kind of solution, because we learn about diet problem in mathematical modeling. For example, AMPL and memories and so on, just food by food. All right, and I said, okay, when I presented it the first time, I'm sure this is going to work. And I said, you never give it a try. Why not we try to give it a try first? Then we'll see whether it works or not. So I tried to prove to the government, say it works. And I tried to do the test run for a different school. And it works. And at the same time, it helps. And from there, I said, okay, probably how can I try to convince people saying that this is very important, all right, for them. I can say that normally we don't have any kind of solutions or approach to help people to make better of themselves, right, their life and so on. For example, if let's say you're suffering from cancer, for example, the only thing that you can rely on is medicine. That's it, right? Chemotherapy, medicine, and so on. Probably some people will say that, okay, I'm kind of done with all the medicines and everything. Is there any like natural way for me to battle with this kind of illness. So it's through food actually, because I know people enjoying eating a lot of food. So why not we try to focus on something that people like, and at the same time,
actually our research should be based on our common needs, right? And so I'm still waiting for audience questions nih. Mungkin Bapak Ibu ada pertanyaan, monggo. Kalau misalnya mau menyampaikan pertanyaan bisa menggunakan bahasa Indonesia, boleh kita akan bantu.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Pak Idris, monggo.
Yeah. I want to ask Prof. Toh Tinlam.
Yes.
May I ask you a question?
Yes, feel free to do so. Thank you.
Before the year of 2000, I heard about kind of calculus. The idea is to change calculus from traditional calculus to new kind of calculus. We call it as reform calculus.
Yes.
In this reform calculus, it gives more stress on reasoning, not on calculating.
Yes.
For example, student will be given a part of graph, and then they will ask what kind of graph this is. Give explanation. So student is not to calculate, but to reason why. Give explanation.
Yes.
But the problem is this program is not going well. So until now, we just still in traditional calculus. We just calculate, find limit, find integral, find something else. You have any information why this good calculus not developed well?
You see, actually, if you take a look, calculus reform, if you were to take a look at the calculus all over the world, I believe in many countries, they are moving in that direction. So as early as I think the 1980s, if I'm not wrong, it is the Germans. The Germans, they themselves come up with this. They realize that calculus in their school curriculum has a lot of problem. They are trying to imitate the university calculus in the secondary school. So a lot of procedures to calculate, but students without really understand. If I'm not wrong, it is the German, I think somebody called Bloom. He has published quite a lot of paper. And I think even in Europe, there is also a movement when more mathematics educators involved, and they realize that this should not be the way of the school calculus. It should not be trying to imitate the university calculus where you calculate limit, epsilon, delta argument, and all these things. So there is a movement away. If you take a look at David Thor from Warwick University, he has published many papers. He has retired many years, but he continues to publish. He talks about the importance of developing in a school calculus is not a lot of this computation, but it's rather to develop in students the concept image. As early as the 80s, he already has many papers talking about technology, which today we start to see it. So like many things, you see, you talk about epsilon, delta, all these things, we are not trying to teach it in the secondary level, but what we are trying to do is we are trying to develop the students' concept image using technology to help them see this is differentiability, this is integrability, okay, all the concepts, this is a continuous function, this is a concavity, etc. In fact, I do see that in many countries' curriculum, there is an effort towards moving that. But how it is enacted in the school is a different story. What is intended is one thing. What is being carried out in the school is another thing. Yes, I do see this. Let me share with you the case of Singapore example. Okay, pardon me, I use a lot of Singapore example because I'm most familiar. In the ministry level, I think they are very sure that technology, everything need to be in place to help students develop this. But because at the teachers level, many teachers, when they were students, they were taught in a very drill and practice way. So when they enact the whole lesson, it becomes something very procedural. Yeah. So this is the problem that we realize about calculus teaching also. Even though the intention is good, but when it's enacted in a classroom, it is quite different. So that's why in my talk, I talk a lot about teachers themselves also have problems with calculus. How they learn as a student, that actually carries forward. So at the curriculum level, I believe in many countries they have moved. But exactly how it is enacted in the classroom, that is a slightly different story. Yes.
Okay. So many teachers just imitate what they learned while they were in university and they teach in high school, something like that.
Yes, 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 yes. And also another thing that I want to add is that it looks to me, I may not be right, but it looks to me, a lot of education research, they focus a lot on geometry, a lot of algebra, very little on calculus, because calculus is considered as a more specialized knowledge. Yeah, so I think this could also be a problem. Yes. And if you get mathematicians, the pure mathematicians will come in, then they will talk about a different world altogether. But if you get the mathematics educators, they may not really touch on the content of calculus itself. So a way is the marrying of these two groups together, mathematicians and mathematics educator, that they can sit down and then think about the mathematics part and the pedagogy part. Yes, this could be something that may be slightly lacking.
Okay.
Sorry.
One more.
Please.
This is just my opinion.
Yes.
I think that calculus, reform calculus, it's matched to this era, technology era.
Yes.
Do you believe that, or do you agree with my opinion?
I do agree. I do agree. How to make full use of the technology is very important.
Yeah.
Like I did mention just now, the use of calculator or use of computer is not to check the answer or not to draw the graph, but is to explore the concept.
Okay.
Yes, I think the part is very important.
Yeah. Okay.
Yes.
Thanks very much.
Thank you.
Okay.
Thank you, Pak Idris. Maybe there is another questions. We have a lot of people that on camera today. We have Pak Muhammad Farhan Rafi, Bu Cynthia Liwana Devi, Bu Zahra Radian. If you have some questions, Bu Mutia Lina Dewi, Bu Maria, Pak Joko, we have Pak Darmadi, we have many audiences. We have questions. No. Okay. Mr. Totilam and Dr. Suryadi, I request you to give your last sentence about our topic today, how to integrate or how to engage technology to strengthen mathematics skill for 21st century. Mr. Totilam, you first.
Okay, actually, why I select calculus, this section, is because there's a lot of room for that. Actually, to me, I think the most important thing that we do with technology is that we must actually transcend what we usually see about mathematics. We always see technology as something that's good to have. But now we are moving in that era that it is necessary to have technology. We are moving towards this. We need to think of ways to how to infuse this in our teaching, enhance our students' learning, and not at the very elementary stage. I would want to say that if you talk about the higher order thinking skills, technology is very powerful. It should actually lead students to develop the next phase of their understanding. And now technology is getting more common because most people will tend to have it. Now, many people have mobile phone and all these things. A lot of things, the cost will be lowered. So that's why more people will have access. Teachers must be able to harness on this to bring the benefit to as many students as possible. Yes. Okay, I will leave it as that. Thank you.
Thank you so much, Mr. Thorsten Lam, PhD. Oh, we got a question here from Buratna STAB and Raden Wijaya. Mohon diberikan contoh teknologi yang dapat meningkatkan motivasi belajar dan meningkatkan kemampuan matematika siswa di masa pandemi. Okay, Mr. Thorsten Lam and
Yes.
Dr. Shadi, I think we need to prolong a bit session because there is two questions that we have to answer. Okay. So I will help you to translate from
Thank you,
Buratna that please give a example of technology that can motivate students to learn and to enhance mathematics or statistics ability of students in the pandemic era during online ability. So it will be based on your experience. What do you do?
Okay, you see, for me, okay, actually, if earlier I'm given more time, I would have used a lot more examples. I've actually cut down. You see, there are many misconceptions that students usually have when before they come to upper secondary level. I can give you some examples. You use some simple technology activities, you can actually get away from that. For example, students always think that the perimeter and the area of a rectangle are related, are directly correlated. For example, okay, the bigger the area, the bigger the perimeter. This is some of the misconceptions that students always have. And later on, when they do application of calculus, they have a lot of problems. With technology like the GeoGebra or whatever, you can actually let them click and drag. It's possible to retain the same perimeter, whereas the areas are changing, or retain the same area, but the parameter is changing. A lot of these simple things, it doesn't take teachers too much time that can have lasting impact on the students. I'm looking at this. I'm not thinking of all the big scale things on technology. I'm thinking of all the smaller day-to-day classroom. Use some GeoGebra or whatever. You can create a lot of this template for the students to explore. I think it is these things that actually makes a difference to the students' learning. And of course, like what I showed you just now, the use of this graphing software, the fact that you can just zoom in and zoom out, you can let students see the concept of differentiability. Differentiability is so deep a concept that only university students can understand. But now with technology, even high school students can understand what it means. Yeah, so I think this is the most powerful part of technology. Yes.
Thank you, Dr. Tadlam. Dr. Sulyadi.
Right,
the same question to you.
Okay,
What do you do? How did you integrate technology to your student in your class?
All right, thank you so much for the question. Thank you, Dr. Naufal. Now, normally, most of the students, this is based on my experience, because I'm teaching queuing analysis, I'm teaching on the management system and so on, industrial management and so on. Normally where we involve mathematics and also statistics, all right? So student will ask me, okay, doctor, we learn about this one, but we don't know how to apply it, you know, because we just involved with a lot of numbers and everything, all the formulas, but yeah, in the real situation, what sort of things that we can apply, probably along with the technology and so on. I said, okay, now let's have a look. Okay, for example itself, if you go to a McDonald's, all right, if you go to a McDonald's for a drive-through, for example, I said from when you receive the order, all right, and then they will ask you what sort of things you like to eat, for example, and you say okay, you make your order, and then you go to the next counter, for example, to pay for your food, all right, and then you have to go for the third counter to receive your food. If you look carefully in the third counter, all right, inside the counter, there will be a screen, and there will be a simple floating chart saying that, okay, what time does this car arrive at the first counter, and what time this car arrive at the second counter, what time this car arrive at the third counter, and how many time it takes for the customer to make a payment, how many times for the customer have to wait in order to receive the food. This kind of technology being applied by using the queuing analysis and so on. So what the motivation that I make for my students is try to relate the theory of mathematics with the real application of technology by using mathematics in a real problem. just like what Dr. Tohting Lam saying that, so we have the theoretical and also we have to implement with the technology at the same time. So that's why in order for me to give some motivation, to increase motivation for the student, I'm just not teaching about the mathematical theoretical, just about the mathematical theoretical. At the same time, I ask them to apply in a real world problem or try to find some example that they can rely on or try to comply together with the mathematics and also with the technology that can be used together in order to solve a problem. So that's why that's the method that I use for the online teaching at the moment. And also I give the same solution for the school teacher, saying that you cannot just teach about mathematics and about the theory, but you should try to implement what sort of things that can be used with the mathematics theory. Probably in this case, we're talking about the technology itself in order to solve a real world problem. So probably that will be my feedback regarding the questions, Dr. Nafa.
Thank you, Dr. Suryadi. Okay, last but not least, question that have been addressed by Pak Darmadi from Odikma. Well, Mr. Tohtilam and Dr. Suryadi, would you please to share your biggest problem of teaching in your classroom during the pandemic, and how did you overcome the problem? What's your biggest problem on teaching during pandemic COVID-19 in your class, or maybe in the school in your country, in Singapore and in Malaysia? Maybe Mr. Tohtilam first.
Okay. Actually, during the pandemic, of course, right at the beginning last year, when we go to a total lockdown, all of us were panic-stricken. As in, suddenly we can't come back to the campus, we can't see face-to-face, so everything must go through the technology. So that's why actually Zoom appeared at the time. And in fact, now I can tell you that, in fact, most of us here, we are very comfortable with, in fact, both students and the lecturers are comfortable with teaching using the Zoom. And we find that it is something that's good. But of course, one thing when you use all this online platform during the pandemic is, I think the physical interaction is not there. So you really do not know whether your students understand or not. Of course, Zoom has all the functions like breakout room, you can have the polling, you can do a lot of things. In fact, it can simulate a lot of things that you do in a face-to-face classroom. But I think, unfortunately, there's something that's still uncomfortable among us, that whether are the students really learning what we are asked to do. I find that this is a matter of the traditional mindset. Just like physically face-to-face in a classroom, even the student is not giving me trouble, I also cannot be 100% sure that he or she is really is understanding, trying to understand what I'm teaching. You see, I think this is a matter of traditional mindset now. Okay.
Sure.
I think a lot of these things, lies in our mindset, I believe. Of course, there's inconvenience. There's a lot of inconvenience, but I think there's also opportunity. Try to tap on this opportunity if possible. Now with technology, I think certain things can be overcome. This is what I believe. But of course, right at the beginning, we were we feel very inconvenient. Yeah.
Okay.
Sorry.
That's the same to me, Dr.
Yeah.
Okay, Dr. Suryadi, what your biggest problem and how did you overcome it? Dr. Suryadi? Dr. Suryadi, are you with us? Dr. Suryadi? Okay, so probably Dr. Suryadi have a problem on in the online. Okay, for online conditions. So let me conclude about the things that about the things that we have discussed today. So ladies and gentlemen, we believe that actually mathematics skills is very important on how to deal with tomorrow's problems. Well, we see that from the economic forum, World Economic Forum, we see that many problems, many jobs and many type of jobs that will be finished, that it will be shifting to a digital job that tends to digital. So that's why we believe that enhancing mathematics skill for tomorrow's or for the next agenda is really important for us. And in here, what have been said, and what has been explained by Mr. Tohtin Lam about how to use technology to enhance student understanding about calculus, especially, and mathematics in bright. So we can believe that we can optimize the use of technology to be integrated in teaching learning process. Okay. And based from what Dr. Suryadi presentations, we see that Dr. Suryadi already used mathematics to overcome the problem about how to use menu. For instance, I really interested with Dr. Suryadi's finding, because I have a problem with the menus in choosing menus, and Dr. Suryadi findings really helped me, especially for us also if we want to get a healthy life. Okay.
Can I add my explanation, please?
Yes, yes, Pak.
Okay, this is related to what Dr. Toh explained, that in our curriculum, in our standard competence, KD 3 ya, dan KD 4, the student should able to explain, and the second word is student are able to solving, not to calculating. Yeah. This in our curriculum. The problem is our teacher in teaching math, they just ask students to calculate, not to explain, not to solving. Okay. It might explain how we solving. We need a technology. Yeah, we need technology. For example, in our curriculum in elementary school, there is kind of question. Okay, we have a tape. The length is 170 centimeters. Okay, and divide that tape into 3 equal parts. Okay, that's the problem. And student will divide 170. Yeah, they call it by long division. 170, 170 divided by 3, and so on and so on. And it's only about 10% of students are able to solve the calculation. 90% are not able to. Okay, because they cannot solve the calculation. The next problem is they cannot divide the tape, the pita tersebut. Okay. Nah, in this case, yeah, the problem is not to calculate, but to solve the problem. How? Just use calculator. This is good. Yeah, 170 divided by 3, we have something. Okay, and then divide the tape into 3 equal parts. That's all. It's only about 3 minutes. But the problem, teacher asks student to solve the problem by using long division. In Japanese, they call it wrong division. That's why we didn't learn about long division in Japan, because this is wrong. Okay. Okay. I believe that many college students, our students, are not able to calculate, to do, what is it called? Long division. Yeah. So what I mean is here, in solving problem, we need technology. Because this elementary, just use calculator. Divide 170 by 3. In 1 minute, finish. and then divide that tape into 3 equal parts. Done. Finish. Yeah. So the doctor in our system in elementary school, students are not able to use calculator. That's provided to use calculator, even though the competence is solving and explain.
Yes.
Not calculated. Okay, thank you.
Okay. Yes.
Thank you, Pak Idris, for elaborating your explanations. Well, we have a conclusion that actually technology is important to be a media for us to understand, to calculate, but actually it's not for us to construct our cognitive skill. Actually, well, thank you very much, Mr. Tohtilam, PhD, for accompanying us today, for enlightening us with your explanation about CPA, and I believe this is very helpful for us and how to understand, to teach calculus in an easy way and in more comprehensive way. Thank you.
Thank you,
Dr. Tohtilam. Okay, ladies and gentlemen, so we finally end up for our last sessions of our discussion for today's conference. So for the last sessions, I will give it back to the Master of Ceremony, Ms. Wilfa. The time is yours.
Thank you, Associate Professor Tohtilam, Dr. Sulyadi Firdaus, and Professor Salma MPD, and also Bapak Noval Isartono MPD as the moderator. Good afternoon, ladies and gentlemen. Before I close this conference, we will have a photo session that will be captured by the committee. And to all participants, please the third slide. 1, 2, 3. The fourth slide. 1, 2, 3. And it comes to the last slide in 1, 2, 3. Thank you to all participants. Happy audience, I would like to remind all participants to fill the attendance list through the link that has been sent in the chat box. All right, ladies and gentlemen, so we have gone through all of these sessions today, and finally we come to the end of this conference. Let's close this international conference by reciting Hamdalah together. Alhamdulillahirabbil alamin. I deliver huge thanks to all the speakers and all participants for attending the conference. If there are any mistakes during this event, my apologies. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. So, ladies and gentlemen, for the few announcements, so we have a bit announcements about the parallel session. So, as what is mentioned by the committee, that for doing the parallel sessions, presenter would be grouped into 12 rooms. the form can be accessed to URL. So I will send it again. I will send it again to the chat box. Wait a minute. Okay, so please find the link in the chat box. Our group. So the author are required to comment and at least 5 videos, papers in their seminar rooms, and report your screen capture discussions on the bit.ly link no longer than Friday, 13 August 2021 at 12 p.m. Then the certificate will be sent to presenter after committee check presenter activity. So the certificate will not automatically generated, but we will check your activity first. Then after that, we will send you the certificate on after Friday. So thank you very much, ladies and gentlemen. Thank you very much for joining this seminar. So hopefully we can meet again in the next ICOMER. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for all.
Pak Joko masih standby, Pak Joko? Pak Joko Untoro?
Ya, masih.
Baik. Sekaligus kami sampaikan ke Bapak Ibu yang lain, telah kami sampaikan sudah beberapa waktu yang lalu, untuk sesi pemakala, sesi paralel ini kita ganti dengan saling komentar atau diskusi di YouTube, paparan YouTube masing-masing pemakalah Pak Adapun listnya sudah kami sampaikan di chatroom Zoom sudah ada, di grup WA juga sudah ada, di web kami juga sudah ada. Begitu. Sudah masuk di grup Pak Joko?
Sudah.
Nanti ada jadwalnya. Kemarin saya juga sudah kirim jadwal untuk sesi paralel atau saling komentar itu terakhir tanggal ini terakhir sebentar Bapak Ibu, mohon maaf.
12 atau 12?
12 ya, Jumat.
Tanggal 13 ya Bapak Ibu, pukul 12 siang.
Ya.
Silakan, ada yang ditanyakan Bapak Ibu terkait teknisnya?
Nyuwun perso.
Silakan. Dengan Bu siapa?
Dengan Bu Andriani.
Silakan Bu. Dari Wade
berarti ini nanti kita mengunggah screenshot dari 5 interaksi kita ya?
Laras, betul
berarti
Bu.
dijadikan satu gitu
Tidak Bu.
5 interaksi itu dijadikan satu file gitu.
Itu sendiri-sendiri nanti submitnya. Maksudnya memang dalam satu link yang sama, tapi bagian inputnya itu sudah kami sendiri-sendirikan.
Pembicaranya dari Malaysia, ada tadi dia ngomong logatnya Malaysia.
Berarti 5 screen
Inggris,
ya?
tapi kejengan lah. Jadi
mohon maaf Bu, siapa nih Ya.
Berarti itu 5 screenshot yang kita jadikan satu dalam satu link itu unggahnya.
Unggahnya dalam satu link, tapi nanti inputnya sendiri-sendiri ya Bu, 5 itu. Kita sudah sampaikan di Google Form-nya.
Siap. Terus berkaitan dengan revisi papernya itu terakhir?
Harusnya tanggal 8 kemarin Bu, sesuai email tapi kalau memang masih ada yang perlu diperbaiki hari ini silahkan, tidak apa-apa.
Sebenarnya sudah, cuma
Nggih.
mungkin masih ada sedikit perbaikan lagi, apa masih diberi kesempatan oleh panitia?
Nggih, boleh silakan segera nggih, Bu.
Nggih, matur sembah nuwun.
Nggih, sama-sama. Pak Darmadi, ada yang ditanyakan? Silakan.
Mas
Silakan
Khalid.
nggih.
Monggo Ibu dulu.
Boleh. Ya. Baik, terima kasih. Terkait dua presenter dari satu artikel, apakah masih tetap dua-duanya membuat 5 komentar atau digabung? Terima kasih.
Nggih, Bu Dian untuk dalam arti menghendaki ini nggih, 2 sertifikat untuk pemakalah nggih. Untuk 2 pemakalah.
Iya, betul.
Nggih, apakah
Iya,
additional
satu artikel.
nggih. Apakah presenter satunya sudah mendaftar sebagai additional presenter